Yeah, hi. Good evening, everyone. So, am I audible?
Yes, sir.
Okay, okay. Yeah, thanks for confirmation. Yeah, so welcome to the session. So today we have planned to discuss the problems which we have given in the mock for the OPP exam. Okay, so that we will discuss the solution. Before that, if you have any query to before the starting the session,
So we have to solve four problem, right? Maybe repeating in the OPP.
uh, yes, you have to solve four problem in 2 hours.
Yeah, okay.
Okay. Yeah, so pattern will be, and each problem will be have the same weightage, 25 marks. Okay, and problems will be so maybe one or two problems will be easy. So as we mentioned that, so you will get maybe some linked list based problem. So we have just released this mock also as the same on the same pattern of the exam. So you will get the similar type of problems in the exam also, but problem will be different, but the topics may be the same. Okay. So, and we have also shared this important topics before in the forum, and we have also discussed in the live session also. Okay, so which topics you need to more focus, and now you can just practice on the similar problems. Okay, any other query?
Sir, could we discuss mock test question?
So that we will discuss. Yeah. So all mock session we will discuss, mock problem solution we will discuss today.
Okay.
Hmm. Yeah, I'm asking that if you have any specific query before starting the session, if you have any doubt. Yeah, Satya.
Sir, do we have to code the queue and stack ourselves?
Your voice is not clear. Can you repeat your question?
Sir, do we have to code the stack and queue for ourselves, or how
Okay,
is it?
you are asking that supporting code like that is for stack queue
Yeah,
this.
yeah, yeah, yes, sir.
So that we generally provided. Okay. So supportive code like yeah stack queue if your algorithm is required that type of supportive code we provided that. Okay.
Okay.
Sir,
Yes, Dev.
I have doubts on some subjects. Can I ask now or later after the session?
Subject means.
Yeah, in the linked list questions, I have some doubts.
Okay, okay. So can you just tell me what's your doubt in linked
And
list?
yeah, on a particular question, I wrote a code, sir, and it is accepting all private test cases and passing everything. But the
Hmm.
same code, if I do it in a lead code site, it is not passing not even a single case.
Okay, so are you following the proper structure? What they are actually given?
Yeah, I'm giving everything, sir. It is actually giving me wrong output.
So maybe some that backend structure may be different. Okay, so you have to just understand the structure, what they are, what is structure they are following actually for the backend. Sometimes some supportive code maybe they have some hidden code in their backend, and you are not following their supportive code. So because of that, okay. So just share the questions. Okay, and at the end,
Yeah, okay, sir.
then I'll check what is the things. Okay. Okay. Any other query? I hope you all have received your slots. Date is confirmed. So we have two slots on 18 and one slot on 25. Okay, so three slots are there for this OPP exam. Okay. Yeah. Okay. Okay, then fine. So let's move to the OPP mock questions, and we will discuss. And I hope our TA is also solving the problems during their session. So we have also shared some problems to discuss in their session. So maybe you are joining us. Okay, one second. I'm sharing my screen. Okay. So I hope my screen is visible to all. So First thing, yeah, this is the interface. Okay, so we have the first problem. So we will discuss, and you can also share your logic if our logic is different. If you are following some different logic, so we will discuss the logics of yours also. So then we will discuss the solution. So regarding the first problem, and first thing, all these mock problems are taken from directly from the previous OPP exam. So these are not different problems, so which we only releasing for the mock. Actually, all these problems are directly taken from the previous OPP exam, and mainly from the initial terms. So maybe you will find out some difficult problem also. So that in the initial terms, the level was a little bit difficult for the problems. Now, time to time, it is reduced actually. Okay. So some graph problem maybe you find difficult. So that is actually a challenging problem. Someone raised the hand, I think. Yeah, Preetodeep?
Yeah. I just wanted to clarify. Are you saying that the actual OPP questions will be easier than the mock ones that you have released this time?
So some problems actually. So graph problem that na. So that is we have
Yeah.
taken from the first term, I think. So at that time we given this problems. This problem was actually a little bit challenging. So generally we ask straightforward questions. Okay, not too much difficult logic based questions related to this graph or these things. Similar on the dynamic programming also. So straightforward easy questions. Okay.
Okay. Got it. Yeah.
Yeah, so mock is basically have some higher level, we can say that. Okay.
Yeah. It makes sense to prepare for a much difficult level and then have
Yeah,
an easy exam. Yeah.
yeah. Okay, so the first problem is also taken from, I think, first or second term. So this is basic problems. We not need to require any specific algorithm in this. So this is simply, we can say that the Python logic based problem. You have solved many problems in the Python. So here also, this is logical questions, not any specific algorithm based questions. So I hope you got the questions. What question is asking that? So I hope this font is little bit smaller for this problem. So I hope this is visible to all.
Yeah. Maybe if you collapse the sidebar, it will become easier. It will take up more space. But the sidebar on the left, if you can close that.
Okay, yeah, this one.
Yeah, the blue color button to the right of that. It's visible just next to this. You will be
Oh,
able to
this one, yeah,
submit.
this one.
Yeah,
Yeah,
exactly.
okay, okay. Actually, I'm using this old UI because of this font. Actually, otherwise in the new UI, this is actually very small. Okay, so yeah, first is swapping min max.
During the OPP, we'll have a choice to switch between the two, right?
Yeah, you can switch. Yeah.
Okay.
So this switching tab will be open this time also. So maybe in the next terms we will remove this old UI completely. Okay, so now the problem is swapping min max. Okay, so what is the meaning of this? You are given two lists name with A and B, all contains the n positive integers. You can apply the following swap operation. So that means one specific operation is given to you, and you can only apply that operations. Okay, to get the answer. So now select index I. You can pick any index I, and I can be 0 to n minus 1 index. Okay, because we have n elements, so this is the possible index we have, and we are picking this index. After that, we can swap the corresponding element from the A and corresponding element from the B. So that means the same ith index we can swap the elements. Okay, so this is the operation. So same we can perform with the vice versa. Now the question is, write a function minmax AB which takes two lists AB of size n as input and return an integer, which is the minimum possible value of max A0 to an minus 1 and B0 to bn minus 1. So that means we will figure out the maximum of the A list element and maximum of the B list elements. Now we will multiply both. So that value should be the minimum actually. That value should be the minimum among all possible answers for this question. So you can get, after applying the swap operation any number of times, possibly 0. So that is the condition is given. You can perform any number of swap operations, but this swap operation will be only performed with the corresponding same index. We cannot sort the list. We cannot change the order of the list. Okay. So that means this is the possible operation we can do. Now example is given. A, we have this 1, 2, 6, 5, 1, 2 element. We have this 3, 4, 3, 2 to 5 elements. Now in this case, we have the possibility of the answer here answer is given. So that we are figuring out that in the case you can apply the swap operation at indices 1 and 5. Okay. So here question is that some problem statement is just frame in this way. So this problem is looking that we have to pick the index and then we have to swap the operations. Okay, so this looks like how we can pick the index, but this is just a problem statement. You can figure out the logic for that. So how you can just find out the minimum possible answer for this. So here this explanation is also given in this way. So we are picking the index 1 and 5 and we are swapping the positions. After that we are getting the new list. Okay, so after swapping this first index, so 2 and 4 you can see. So 2 and 4 we are getting this 4 is coming in the first list and now 2 is shifted into the B list. Okay, and same way we are picking the this fifth element. Okay, so fifth element we have swapped. After that, if we are figuring out the maximum of the first list, so which is actually 6, and maximum of the second list, which is actually 3. Now we are multiplying this, we are getting 18. So this is the one possible answer, and this is actually a minimum. If you figure out any other, you cannot figure out any smaller answer compared to this. So this one explanation is given. Here the logic is not defined. This explanation is given directly, just picking some index and swap the elements. But how you will decide this swap the elements, which index should be swapped. So that is the logic required, which you have to write. Okay. So now sample input is given, and you have to that figure out the answer for this. So suppose if we pick this without any swapping operation, so what will be the answer? So in A list, you can see we are getting 6 as the maximum, and B list we are getting the 5 maximum. Okay. So in this case, 6 into 5, 30 we are getting. But after performing some swapping operation, we can reduce this. So in this way, instead to finding out the random index, what we can do, yeah. So before discussing the solution, yeah, anyone, if you want to tell the solution, anyone from your side?
Sir, I got confused with the
I can give a try.
question.
Okay.
Like, how do we know which index we should be
So
swapping?
that is just a problem statement, because the question statement also cannot that release the solution approach. Okay, so that just pick the random index to just give the explanation for the answer. Okay, so that means we are getting the minimum answer if we are doing this index swapping. Okay,
Okay.
you have to
Because
figure out that how you can figure out the minimum answer. You can apply any other strategy also, but you can only perform the swapping operation according to the problem statement. Okay, so that approach here we will discuss. Yeah, Biswas, so you want to try? Yeah.
Yeah.
You have.
So what we need to do is, based on the index, we have to take all the smaller element in one list and all the bigger element in one list. So meaning, like, if the 0th position in the A list is having the smaller element, let's say we are maintaining A as the smaller, then no change. But if it is having the bigger element, then we will swap the position based on the index and their value.
Okay.
And if we do this for the length is equal for both, then if there is a lesser value, we swap, otherwise it is retaining, and then finally we take the max of both and multiply, we get the solution actually.
Okay, yeah, that's it. This is the correct approach. Any other approach anyone is trying for this and got the answer? I also want to just know that if anyone is trying any other approach, because as Biswas, what approach is actually mentioned, that same approach actually we are also following. If anyone is approaching any other logic, because any problem may be solved in different logic also. So I'm just trying to ask if anyone have tried any another logic for this.
Sir, I tried one approach, and
Yeah. Yes, Satya.
public test cases are passing, but
Oh.
one private test case has passed. I don't know what are the three. So what I did is I compared the element by element in two lists. If
Okay.
the bigger element, I mean, if it is bigger than the, I mean, the bigger element will go in the A list, and the smaller element will go in the B list. And
Okay.
at the end, if I find the maximum of both the lists, then
So this
that
approach is looking correct. Same approach actually Viswas is
I use
told
the
that.
same approach and I passed all the test cases.
So maybe some that you did some code error, maybe some indexing or something.
Did you sort the two lists after exchanging the values?
no, we don't need to sort. I mean, we
Yeah,
just
we
have
can't
to
sort.
find the maximum value of uh, the lists.
Yeah,
I
right.
mean,
So yeah, I did it. I
whenever
did
I
that
was
only.
traversing, I was finding the maximum on the way. I mean, that way I didn't have to sort.
So
And
sorting is not required, but yeah, what approach you are saying that is correct actually. So maybe some your code error will be there. Maybe
maybe
you
some
missed some things. Yeah,
corner
otherwise the
case.
approach is the same which Viswas is actually mentioned, and same approach we are discussing today.
Okay.
So here we have this just 1 second.
Sir, just a small note. What are we discussing in this session?
We are discussing the mock problems solution.
Okay. One
OPPE mock.
one more thing, sir. Is this a session and going to be different from the prior sessions?
Prior session means
Previous term sessions, previous term OPPE mock.
So if previous terms, if the problems are same, that since this is the same actually. If you have already seen that session, so maybe you will get the same solution.
Okay, sir.
Okay.
Thank you.
Yeah, problems are same actually. Okay.
Okay,
so
sir.
So yeah, okay. So here what we can see, we can take two this 1 2 6 5 1 2. So I'm taking this. Okay, so we have this equal to 1 2 6, and we have this 1 2 6 5 1 2. Okay, so 5 1 2. This is the A and this is B we are taking, and for the sample, and this is actually 3 4 3 2 2 5. 3 4 3 2 2 5. Yeah, so this is the sample input we have given. So here we can only perform the swapping between this index. Okay, so this is 0 index 1 2 3 4 5. Okay, so we can only perform the swapping operation, and after that we can figure out the max from this and max from this, and then multiply. Okay, so this answer should be minimum. So in this way, what we can do, we can compare each index element. Okay, and we can shift all the, during the comparison, if we can shift all smaller element in the one list, Ath list, and bigger element into the B list. Okay, if we perform this operation, so all smaller element will come in the one or the first list, and corresponding all bigger element will be come into the B list. So here in the multiplication, how we can reduce this multiplication value. So if all bigger element is coming in the B list, so only the one biggest element will be selected as the maximum element from that, and another maximum element will be selected from the elements which are actually smaller element compared to the corresponding bigger elements. Okay, so in this way we can reduce this multiplication to the minimum solution. Okay, otherwise if we are not following this operation, so definitely you may get the chance, you may get the two maximum elements from the both list. Okay, but here we will get a one maximum and definitely one from the minimum elements corresponding to each index. So we will just simply compare the elements. So like what condition we can do, so we can take the ith value from 0 to 5. Okay, we will compare each element index by index, and after that we can take condition either like this. So ai, if ai is less than equal to that bi, like this. Okay, so we can take this condition and then we will perform the swapping operation. So swap is just like a simple ai and comma bi, and then we in Python we can directly swap like this. So that bi and ai. So we will write this line. You can also change in the different way. So what happening in this way? So if ai is less than equal to bi, okay, so ai element is if smaller than bi, then we are swapping. So that means smaller element is moving to the bth list, b list. Okay, or what you can do, you can just change this condition like this. So ai, if ai is greater than bi, then swap the element. So this smaller element will come into the ai element. So all corresponding smaller element will shift it to the ai element. Okay, so just run a loop for each index and check this condition and swap the element. So in this way what will happen, so we will get like this. Suppose if we are following this condition ai, if ai is greater than bi, okay, so if bi is smaller, is the small element, then we will swap that element position. So small element will shift it to the a list. So here you can see first condition. So what will be the updated list now? So in this way, so here ai is greater, so 1 is greater than 3, no. If this condition is not true, we will not do anything. So okay, so 1 and 3 will remain same. Now second, 2 is greater than 4, no. Okay, so 2 and 4 will also remain same. Now 6 is greater than 3, yes. So here this 6 element, this smaller element will shift into the a, and 6 will be shift into the b list. So here 3 will come and then 6 will come here. Okay, now 5 is greater than 2, yes. So again we will swap this. So 2 will come in the first list, and now 5 will come into the second list. And same 1 and 2, yeah, this is already fine. So 1, 2, and 2 and 5, yeah, this is already fine. Okay, so in this way you can see now all smaller element corresponding index, all smaller element now shifted to the a list, and all greater elements shifted to the b list. So now we are checking this index comparison for each index. Okay, and we are shifting our elements like in this way. So in this way, according to the explanation, only two indexes mentioned that, because the problem statement cannot be disclosed the logic. So now we are also following the same way. We are just figuring out our minimum possible answer. Now you can pick the maximum from this smallest element list 1. So you will get a this 3 answer here, and from this you will get a 6. Okay. Now this will be the answer 18. Okay. So in this way, you can write the code for this logic, and this is very only 2-3 line code. And I hope if this logic is clear, you can write the code also. So here, so yeah, in one more thing, in the OPPE exam, most of the questions you will find out the function-based things. Okay, so you have to write the function definition. Some in some question, some code will be given, which you can see that some code will be given in the visible form, that suffix or prefix. Okay, do not try to remove that. That is actually the part of the code solution. And some code, some part of the code will be given as a hidden code. Okay, so only read the problem statement, figure out that what's your actually task, what you need to do in the question statement. Do not try to read the input, and if only function writing is asked, do not try to read the input directly. Okay, so already reading input and all these things already done in the suffix or prefix like this code. And most of the problems we have mentioned the template, like definition, then function, the template. Okay, what is the function names and this thing, only you need to do just a middle part. Okay, so that definition, body part of the function. Okay, so this part, just take care of this. Sometimes some you will get stuck in one two problems. Okay, so that will maybe you will get waste of your time. So for this problem, so we will write the function. So you can see min max function is required. Okay, so the function name is the min max. So write the function, and we have the two input for this. So that is a comma b only, and after that. Okay, so here just run a loop. So that one loop is required only. So for I in range, and what we have range, so then we can take any length of the any list, because the length is same for the both list. And for this list, we will simply check the condition. So if ai is greater than like bi, okay, and if this condition is true, then we will swap the elements. Okay, so a of I comma b of I, and then equal to b of I comma a of I. And now this condition is complete, and after that we will just return a answer of max of a and multiply max of b. Okay, so now this is the required function for this, and yeah, all test cases are passed, so you can try this logic. Okay, so this is the problem 1 solution. I hope this is clear. We can move to the next.
Yes, sir.
Okay, so yeah, next problem. Yeah, so linked list is very important topics for the OPP exam. So in the many previous terms, this questions are asked from the linked list. Okay, so here some problems are given: remove duplicates from the sorted linked list, and one more problems we have the mock PPA 3 also. So that is merge to sort linked list. Okay, so in these questions, so there are multiple possibility of the questions. So like this is actually duplicate from the sorted linked list. So that means elements are sorted, and you need to remove the duplicates. So at the end, only distinct elements should remain in the same. Uh, and another is only that basic operation based on the linked list. So the problem 1 actually we give as a that easy problem. So the linked list operation, like just remove one element, remove a element from the end of the list. So remove element from the starting of the list. Okay, insert new element at the end of the list, insert new element from at the front of the list, and some kth position is given, like if remove the 5th element from the linked list, insert the element at 5th position in between. Okay, so this type of basic operations, like here you need to write any specific function, so that will perform that operation. Other the remaining part will be given as a prefix or suffix, sometimes hidden also. Okay, so here you need to understand the structure of the that linked list, what structure is given. So here we are asking that remove duplicate from a sorted linked list. Okay, so what is the structure of node? Node structure is given. That means each node have these two fields, uh, data field and next field. Data contains the data actually, that what data we are storing inside this, inside the node, and next contain the reference of the next node. What's the next node connected to that current node? Okay, if there is no node connected to the next, that means it will contain the none value. Okay, so this is the identification basically for the end node. So here that diagram is also given for the linked list. So we have one head pointer that contain the reference of first node, then first node contain the reference of second node, like this, and all nodes are connected. So this is a singly linked list model, and last node contain the none value in the next field. So that means this is the identification of the last node. Okay, so this is singly linked list structure is given. Now, so one basic operation you should know about the linked list, especially singly linked list, how you can traverse the list. Okay, how you can traverse the list. So definitely you should know the traversing each element if link head is given. Okay, So that if you know this traversing operation, definitely you can perform any operation. Okay, just remove the element, insert the element. So that means traversing is the main important point for this. After that, you need to simply change the reference. Just remove the reference, update the reference, create new node, and that update the reference only. So this linked list only performed based on the just update the reference. Okay. So in this way, now what is the actual question? Write a function, remove duplicate head, where head is a reference of the first node and of the sorted linked list. The remove nodes with duplicate value from the given linked list. The function should not return any value. Yeah, this is also important point. You need to perform only this operation. You need to just remove the elements. Okay, do not return or print anything. Okay, do not try to print operation, do not try to return something from your function. So that part will be handled by the suffix code. Okay, so that means just update the same input list. Do not create a new list. So update the same list and leave it. After that, the suffix code will read, traverse the same updated list and will print the output. Okay. So in this way, this is the important point for this type of questions. So just read the problem statement carefully. So here you can see, so nothing is given, suffix prefix. So you need to write only this remove duplicate head. Okay, that head function. So remove duplicate function you need to create for this problem. So now what is the logic to remove the things? Here list is sorted, so that definitely duplicate elements will come as a neighbors elements, continue in the continuous way. Yeah, so what you can do, if we just follow the logic for this, so what we will do, we will set, so we have the structure. Okay, so your logical view should be clear for this question. So you have the one head pointer, and head is just a point to the first node of the list. Okay, suppose this node contain one value. Okay, now we have the next node, and this is also contain one, and next is like this two. This is list is sorted. Okay, so element will definitely come in this type. Okay, so two, and then two. Okay, then now we have this three. So you can figure out the logic. Just take some small example. Okay, and just check how you can do this. So after that, what you have to do, you have to take some pointer. Okay, so that suppose if you're taking one pointer like temp pointer and just initialize with the head value, and to figure out the duplicate, that means you need one more pointer, and at that time you can just compare the value of the, so that means one temp, we will just take, suppose this temp pointer is containing the reference of first node. So we should take one more pointer, and we can give any name like temp one. Okay, so temp one, and this is, suppose this is temp one and this is temp two. So what we will do, we will set this temp two to the next, just the next node of this. After that, what we can do for this? Okay, so
for
we
better
can say,
understanding, you can name it previous or prep.
name you can give anything. Okay, so this is the current, or you can just is next. This is also fine. Okay, next and current, because previous is now we generally takes if we are pointing three pointer at the same time: current, previous, next. Okay, so I think current and next is also better to understand this. Otherwise, if you have the clear understanding for the problem or the solution, then you can take any pointer. So I'll generally take like temp one, temp two, this. Okay, so after that, what you need to do, just run a loop. Okay, so first you need to do all the operation you need to do under the while operation. So that means how many times you will repeat the operations. So we just take one condition while, and inside this while condition, and because here temp 2 is just moving to the ahead of this temp one more next position to the this one. So what we can do, we can set this our temp 2 while our temp 2 does not equal to none. Okay, so why we are taking, so we will repeat our process the while temp 2 does not equal to none. So does not equal to none means that our temp 2 will reach at the last node. Okay, so this next temp2. So that means every time we will shift this temp2 to the next position. So we will read the reference from this next position from the each node. So in at the sometimes we will reach at the last node and we will read the this next element. So this is actually a none. So we will store this none into temp2, and at that time we will stop the process. Okay, so because we have reached the last node. So inside this loop, you can take any condition. So that means we need to process till the end. Okay, we need to process till the end, and we will perform our logic, and we will just repeat the things. And what is the logic? So after setting this temp1 to the first node, temp2 to the second node, simply check the value. Okay, if value are same, okay, if value are same, that means you have to remove one element, because now both are same, that means it is duplicate. So just remove the elements. And for remove the elements, what you can do, you can set your temp2. Okay, so you can just move to the temp2 to the next element. Okay, just move to this temp2 equal to how you can move to the next element. You have to write like this. So temp2 dot temp2 equal to, okay, so temp2 dot next. So what is the meaning of this? So that means we are assigning a new value in the temp2 variable. Current this temp2 is now pointing to the second this element. Okay, now what we are assigning into this variable now, so temp2 dot next value. Okay, so the what is the value inside the next field of this current node. Okay, this node. So that is the reference of the next node of this. So that means this temp2 will be updated by the next node, this 2. So this temp2 will now move to this location. Okay, so now temp2 will point to this. Okay, now after shifting our temp2 like this, we will update the reference here. Okay, so that means we will so now the temp1 next, this next contain the reference of the this element. Okay, the duplicate element. Now we will directly link to this element. Okay, so we will set our this next field directly to the this second element after just ignoring this. So how we can do this? So we can simply write temp1 dot next. This time we want to update this field. Okay, so we want to update this field, and what we want to store in this field, that is actually the reference of this node, and the reference of this node is now inside the temp2. So we will simply write temp2. Okay, so now this link is updated and this is removed. Okay, so in this way we will perform the same things again. If we are removing the elements, that means if we found the duplicates, we will perform this operation. Okay, now we will repeat again same things. Okay, now we will check the same temp1 or temp2 is equal or not. Okay, and we will again perform the, if it is duplicate, then we will again perform the same things. If it is not duplicate, in that case we will shift temp1 or temp2 to the next positions. Okay, so suppose now temp1 is pointing to this 1 and temp2 is pointing to 2. Now the value are not same. So in that case we will shift our temp1 to the next node and temp1 to the next node. So that means we will now we are not finding out the duplicate, so we will check the next elements. So in how we can just update this, so we can write temp1 equal to temp2. This is the first thing. Okay, now temp2 address is saved inside the temp1. So temp1 is now reached at this position. Now temp2 equal to temp2 dot next. Okay, so dot next, this contains the reference of this node. Okay, so now this will store this. Okay, so in this way all both element will be moved to the next element, both pointer. So this is the two condition we have. If elements is that same, then we will remove the element. If not same, we will move to the next checking. Okay, so now you need to write the logic for this, and so how we can write? So the function name is remove duplicate. Okay, so we can simply write remove remove, duplicate, and we have the head as the input. And inside this, the set our pointer like this. So temp1 equal to head. Okay, so this head is given, and temp2 equal to head dot next, or temp1 dot next. You can do anything. So, okay, so head dot next. After that, just run a loop while, and inside this loop, just check temp2.
Excuse me, sir.
Temp2, yes.
So what if the input list has just one node? So what if head dot next does not even exist? So don't we need to like somehow cover that case as well?
So if it is not if no element exists to head dot next, so that means you will get a none.
None. Okay,
Okay.
yeah, right.
In that case, while loop will not run. It will terminate in the first iterations.
Okay, got it. Yeah, thanks.
Yeah, so temp2 does not equal to none. So we are running only this loop if temp2 is not equal to none. So this condition. Okay, and after that we will check our condition. So if like temp1 dot data
Equal to temp2 dot data.
Equal to temp2 dot data. If this is true, then we will update our pointer. So as I mentioned that we will update our temp2 now. So temp2. Okay, temp2 equal to, and how we are setting that? Yeah, temp2 equal to temp2 dot next. So first we are moving our temp2. So temp2 dot next, and then we will update our temp1 dot next. Say temp1 dot next field by temp2. Okay, so in this way now we have removed the element. Okay, else we will shift. Okay, so else we will shift.
Sir, shouldn't line 6 and 7 be swapped? Because temp1 is the current one, right? So we should set that first, and otherwise we are changing the value of the next node itself.
No, what we are doing, so what you are saying that it's update our temp1 first, correct?
Yeah.
So then you have to change the instruction for that. Then you have to write like temp1 equal to temp2 dot next, correct? Because now temp2 is pointing to this node. Initially temp1 we have this. Okay, temp2 we have this one. So if you want to update this first, so you have to write like temp1 equal to temp2 dot next, because we want to set this pointer to here.
Correct.
And then you can do temp2 equal to temp2 dot next. So same things we are doing. Okay, so you can do in the different way also. So both are correct. Okay, so here what we are doing, we are just shifting temp2 first. So are we losing anything if you are doing in this way? Because we are just moving temp2 first, then we are updating the address. So we are directly writing like this. Okay, so your instruction is also correct. You can also follow your instruction. So temp1 dot next is now updated. Otherwise, what we will do, we will move to the both pointers. So temp.
Sir, could you? I'm sorry. This line 7, I'm unable to visualize. Could you just explain that in the diagram once again? The one node.
Temp1 dot next.
Yeah. So when you're changing that to temp2, aren't we like skipping over one node and going to the next one?
What we are doing? So you can see both. Okay, let me just make another one for clarity. Okay, so this is head, and I'm writing like 1, 1, 2, 2, 3. Okay, so now suppose this temp1 is now pointing to this. Okay, it's now. Let's write like. Okay, so temp1 is now pointing to the first node, this one, and temp2 is now pointing
Second
to
node.
this node.
Yeah.
Okay, this is fine. So what we are doing, if value are same, so we are shifting this pointer to the next node.
Right. Okay.
Okay, and then we are updating this position next. Okay, so this one is coming here and this is the pointer. Okay, so we are updating this pointer. So temp1 dot next equal to temp2. So now temp2 is shifted to this position. Okay, so we are directly storing temp2 address inside this. So temp1 dot next, this is the location equal to temp2. So temp2 is now referring to this, so that
Yeah.
is stored.
Got
Okay,
it. Yeah.
which is
Now I
link.
understood. Yeah. Okay. It's the same thing. Yeah.
Yeah, same thing. Yeah. So you can see this is the same. Otherwise, we are simply updating our moving our both pointer to the next. So temp1 equal to temp2. So now temp1 become to the position temp2, and temp2 just temp2 equal to
Temp2 dot next.
temp2 dot next. Okay, yeah, this. Okay, so yeah, this is the only logic required, and it will work. Okay, this is working. So now you can practice on the similar type of question. So this is the basic questions, insert and delete. Okay, so this operation is basics. You can see the implementation which is already given in our notes. So you can see the implementation that part. Otherwise, basic operations like here duplicates, remove the duplicates. Otherwise, that reverse the list. Okay, so that is also one. Reverse the list. So in that case, I think that problem is already given in the weekly assignment. Reverse the list. Okay, so in that case, you need to just reverse the pointer in the another direction, and at the end, just store the reference of the first element.
Sir, here in this pictorial drawing, what when we are dropping the second element after finding the duplicate, they're moving the temp2 to the head of the third one, which is fine. But what you are pointing to the temp1, because the two split what it has, first one is the head and the second one is the value, right? I mean, see, you are writing the temp1 dot next is equal to temp2. That
Okay.
So my doubt is the temp2, the first part of that is the head and the second part is having the value, right?
Yeah, I've written these things. Okay, so this is not clear to you. You are saying.
Yeah. That second line
So
after
okay,
finding the
what is
match.
the okay? First thing, what is the meaning of this? Which part is it is referring actually? First thing, always if we are writing any assignment operator, okay, so like A equal to B. Okay, so what is the meaning of this? So meaning of this is we are storing the value of B at this location. This is always a location. Okay, and this side is a value. Okay, so just read this statement like this. So the value of temp2 store at this location. Okay, so what is this location? Temp1 dot next. So temp1 is pointing to this complete node. Dot data is referring to this field. Dot next is referring to this field. Okay, that means we are assigning a new value to this field. Temp1 dot next. This is not a position of the element. This is a field. This is a location. Okay, and this is a value. What value this side we have? So temp2, what value it actually contains? This contains the reference of this one. Okay, so that reference will be copied to this area of the node. Okay, so
yeah,
this will become a logical link to the second this node.
So at that point, sir, what will happen to the middle one when we have?
Yeah, middle one is now lost because we have removed the link. Okay, so now how actually this was linked, because we have the reference of the second element in this field. Now we have updated this field, and we have updated by the new reference. So that means this is lost in the connection. Okay. Yeah, that will not come in the traversing. If you will read the list again, so that means directly from here you will directly jump to this position. Okay, so now this is actually disconnected from the list. Okay. Okay, so I hope this. Yes.
With the traversing, like the reversing the list totally. So
so reversing the list, you have to change the pointers, that reference. So same things what you have to do. You have to just read the element like the same way, temp1, temp2, like this. Okay, and in this way, what you have to do, you first node. Okay, so first node in the next field, you have to set up the none value. Okay, suppose if you have list like this, that head is the pointing to the first node. Okay, like this is one. Okay, and this is connecting to 2, this is connecting to 3, and this is connecting to 4. Okay, now we want to reverse this. Okay, now what happened, this contains the none, so this is the last node, head pointing to this node, this is the first node. So what we will do, we will just traverse the same list from the head. Okay, and we will maintain 2 pointers like this. So temp1 is pointing to this. Okay, and temp2 is pointing to this. Okay, so first step, what we will do, because now we have set our temp2 to the second node. Okay, so now we have the reference. So what we can do, we can set none here. Okay, none in the temp1 field. Okay, so that first step we can do. Okay, at the directly, so temp1 dot next equal to none. Okay, after setting the temp2, do not perform like this. So first you set the temp1 equal to none, and then you want to figure out the temp2 equal to temp1 dot next. So that means you will lost the data. So first you have to set up this. Okay, so temp2 equal to temp1 dot next. Then you have to assign this temp1 equal to none. Okay, then you will get a temp2 correctly. So after that, what you have to do, every time you will traverse under the while loop. Okay, so you just check, run the loop in the same way. So while temp2 does not equal to run like this. So every time what you need to do, so temp2 dot next. Before that you have to move also. Okay, one more thing, I think you need to take one more here, because like temp3 we have to take. Okay, so temp3 will point to this. Okay, after that what you can do, just reverse that link. Okay, so for reverse the link you have to do like this. So temp2 dot next equal to temp1. Okay, so now this link is connected to this. Okay, now after performing this, set your temp1 to this position. Okay, so in this way, like you can write like temp1 equal to temp2. Okay, and temp2 set your temp3, and temp3 set to temp4. Okay, that temp2 dot next, like this. Okay, so set temp3 to temp3 dot next. Okay, so after updating this link, so that means your all pointers is now moved to the next. So that means temp1 is coming to here, temp2 is now here. Okay, and temp3 is now come to here. Okay, then do the same things. Okay, so just update the temp2 dot next, this point equal to temp1. Okay, so this will become like this. Okay, so now all your links are now reversing. Okay, just do the one more time, and again just update this link to next to this point. This. After reaching at the end, so which variable contain the reference to the last node, update your head to that temp2 or temp3, that which actually variable is containing the last reference. So just update your update. Okay, so now all link is now reverse. Okay, so all links are now reverse connected, and update your head to this position at the end. So now this link is reverse. When you will traverse this list again, so that will start from this side. Okay, so 4, then 4 is now connected to this 3, then this 2, then 1. Okay, so in this way you can just reverse the list. I think this question is given in the week 3 assignments.
Okay, sir, thank you.
Okay, so in this way traversing is the main part. Okay, so that while loop we have required, and under the while loop just update the things. Okay, update the reference. So that reference update is the main part of this. Yes. Okay, so I hope this is clear. So mock 3 question is also related to the same linked list. Now here the merge sort, that concept is also involved. Okay, that merging only, not merge sort completely, merge 2 sorted lists. Okay, so now this is given for the linked list. You know that how we merge 2 sorted lists. Now the same concept you need to apply on to merge two sorted linked list. So you have the same linked list structure. That means each node contains these two fields. Now you have two pointer head 1 and head 2. Okay. So write a function merge sorted list head 1 head 2 where head 1 and head 2 are the reference of the first node and two sorted linked list. The function should return the reference of the first node of the merge sorted linked list. So here you need to create the linked list also. So just read the element from two list and create a new list. So logically, how we can do this? So that means we have two lists here. So head 1 is pointing to one list. Okay, so that like 1 and then 3 and then like 5. Okay, and then 6, like okay, 7. And head 2 is also a list that contain like two same element maybe also we happen like okay, so 3 and 4 like this. Okay, so this is none. So how we will, so both are the sorted list. Okay, so 1 3 5 6 7 2 3 4, both are the sorted list. Now what we will do, we will create another variable, so like head 3. Okay, now initially this is empty, so that we can set the none initially. After that we will set two pointer here. Okay, so one temp1 you can take for the first list and temp2 you can take for the second list. Okay, after that simply compare the temp1.data and temp2.data. Okay, so run a loop. Okay, and
Sir?
hmm.
So this head
Yeah.
3 we are generating on our own. Is it a new node that we are making?
Yeah, you need to generate on. Okay, so this
Okay.
is simple variable. You need to just simply connect the node, and to create the node, you have to call that class. Okay, so that this class node class. Okay, so just create this class, so you will get a one object for this.
Okay, got it.
So like this is, now this is simply merge operation. So you need to follow the merge thing. Now you have two pointer, and so just take the condition while temp1 does not equal to none and temp2 does not equal to none. You know that there is a chance if both lists contain the different number of elements. If both have the same element, then it is fine. Otherwise, what will, there is a chance that if all elements of head 2 are smaller than the first element of the head 1. Okay, so in this case what will happen, when you will compare the element one by one, the all head 2 elements will come first. After that your head 2 elements will remain same, so you have to traverse the head 1 later completely. Okay, directly you can add, or your element directly come like this. So first element is smaller than the second, then you will pick the first element. Okay, then second is the next smallest, so you will take it, you will take from the second element like this. So that means you need to compare the temp1 dot temp2, but there is a chance that if maybe elements, some elements remain after the all comparison complete. So some maybe more than one elements are remains in the any one of the list. So you need to check that if any elements is remaining in the other list. So if yes, so just read all the element and just insert into the new list. So in this case, you have to take one condition like this. So while temp1 does not equal to none. Okay, and temp2 temp2 does not equal to none. Okay, so this is the one condition. So that means if this condition is true, that means both lists have the elements, and then compare the elements. Under this condition, if both temp1 and temp2 is not reached at the last node, so simply compare the element like so. If temp1 dot data, okay, is less than equal to temp2 dot data, okay, then what you need to do, just create a new node in the head 3 list and read this data and store this data to the new list. Okay, so because this is the smaller one, okay, temp1 data is smaller, this condition is true, so this data should be moved to the final sorted list. So in that case, so what you can do, if this condition is true. So yeah, here you have to check that this is the first time you're checking this condition and this condition is true. So in that case, what you can check this condition if had 3. Okay, so had 3 is equal to none, because this first time you have to add the first element. After that, you have to add the element using the next dot next, like this. Okay, so if first time you are doing this comparison, so just add as a first element. Okay, so that will become like a had 3 equal to node. Okay, so or you can, okay, 1 second, one.
Sir, we can
We can have a
create
temp
this.
variable, right? Temp 3.
Sorry.
We can create this before everything else. Means before entering the while loop, we can create a new
Node, you are saying. So that we can also do. You can create a node, because every time if this condition is true, so you can create like a new node. So okay, new node, okay, equal to node class, and just leave it. Okay, that is the empty things. So now that means new node is created, and in this case, so just create this new node dot sorry, had 3 equal to new node. Yeah, this is now linked, but you have to also copy the, like, so new node, or okay, one thing, if this condition is true, so yeah, this is, yeah, one more thing you can do. So you can create a node here, okay, with the data. Okay, so that means new node equal to node, and pass the data value also. Okay, so temp1 dot data. So that means data will also be stored. Okay, so in this way, instead of here, if this condition is true, and create a node with this data and add this node. Okay, so here just write it like this. Okay, had 3 equal to new node. Okay, else another condition, if this is not equal to none. Okay, so had 3 is not equal to none. So that means this is the had 3 already contains some element. So at that time, what you can do, you can simply okay, so that means every time you have to add the element at the end. So how you can maintain this? So what you can do, you can take another variable like temp3. Okay, and always keep the reference of the last node in this variable. Okay, when you are inserting a new node, always contain the reference inside this temp3, so that insert operation will become easy for this. Okay, so what you can do at the time, at every time when you are inserting, so also contain this temp3 equal to like this new node. So this new node is the last node every time. Okay, when you're inserting. So how after that, how you can insert directly using this temp3? So you can simply perform like temp3 dot next equal to new node. Okay, and after that, temp3 equal to new node. So this is the condition. If temp1 dot data is less than temp2 dot data, so this we have written for this, then we have to write the else condition for the same. So just write the same code for the else condition when temp2 data will be copied. Okay, if this condition is not true, that means temp2 is smaller or equal. So in this case, just update all the things in the same way. Instead of writing temp1 dot data, just update this temp2 dot data. Okay, other will remain same. So now this is the condition when both lists have the elements. After that, after completion of this part, just write a another condition if, then check one more time inside the while loop. Okay, not while loop. Okay, yeah. Okay.
Sir,
So
if
what?
Right.
Yeah, you can run a while loop also here. Okay, so if this is complete now, you can write a while loop. While only one condition. So temp one dot does not equal to none. Okay, does not equal to none. So just run a single loop. That means we are checking that if any element is remaining in the first list, so then we will simply add all the elements in our final list. Okay, so we will simply write like this. So temp 3 dot next equal to new node. Okay, so that node we can directly create like this also. So temp 1 dot data. Okay, now this is added. This is added. Okay, and temp 3 equal to node that.
So,
Yes.
so instead, we can directly link the node. No, sir.
You can directly link. Yeah, that also is fine. You can. Yeah, that I actually wanted here. No need to run a while loop. You can directly that link. Okay, so which is already available. You can check the condition if temp 1 does not equal to none. Okay, so what you can do, you can set directly your temp 3 dot next equal to temp 1. This is the one step here. So that means what list is available from this point. Okay, so temp 1 is pointing to the one middle point in maybe, and after that some elements are remaining. So what you can do, you can directly add the reference of this point to the your temp 3. So all remaining element will be added directly. Reference will be added. Okay, and same things you can check for the if temp 2 does not equal to none, and do the same thing. Temp 3 dot next equal to temp 2. So all remaining element will directly link to the new list. So in this way, all elements will be come in the final that final list. All element will come in the sorted order. So you will get a final sorted list after the merging. So this is the merging operation. You can see the algorithm of merging. Okay, the same things we are performing. If you remember the merging operation in the nodes. So let's show you that quickly. So he has seen that. Okay, this is the two merge sort. Okay, so merge sort. Yeah, this merge operation. If you remember this. Okay, so we are checking this condition for the both list. If I is less than n and j is less than n. So then we are checking this and appending the elements. Case 2, if only b is over, a contains some elements. So we are checking this while loop and we are appending all the remaining elements of the a list. And then we are checking if the a is over and b contains some remaining elements. So that means we are appending all the b elements in the final list. And after that, we are returning this. So the same algorithm we are here pointing here on the linked list. So you can do the same algorithm. I hope this is logical part is clear. Then you can try to write the code, because or do you want to write the complete code here? You can do this, or shall I write the complete code? I think we have 8 problems.
Some
so
students have already shared their implementations.
Oh, in
If
the
you check the
chatting?
chat box, yeah, in the chat box,
Oh, that's it. Fine.
two implementations have already been shared by 2 students.
Okay. So let me copy one. Yeah, because later problems are actually the problems. Yeah. So let me try this one solution. So which actually Dave is shared. So here. And let's run this. Yeah, it is perfectly working. So let's see this code. You can see we have this head 1 and head 2. So that means both is not equal to none. Okay, so this condition is representing the same things. Then we are simply checking the elements and min. See what we are doing. Okay, this min we are setting the data, and we are setting head 1 equal to head 1 dot next. What is this?
So he's just taking the minimum of the two nodes.
No, finally, which is the final list pointer?
T dot next. I think so. I think both of their implementations are creating a blank dummy node. The first node is like
Okay,
just blank.
T node. Head 1 equal head dot. Okay. This head 1 is pointing to this. Okay, so yeah, that part is we are linking here. Okay, fine. Yeah, so this new is actually a head point for the that list. Okay. So new dot next equal to node min, and after that new equal to new dot next. Okay. And t is now t dot next. Okay. So this is also fine
T is a
because
blank.
so t is actually blank node, and that is representing the head for the final list. Yeah, this is also fine because what we are doing, we are copying the min element, and we are moving our head one to the next. Same way, if this condition is not true, we are setting our head to to the next element. Yeah. After that, we are setting our element to the final list and moving to the this third pointer to the next. Okay. And if this condition is true, we are directly adding. Yeah. This is the same logic which we have discussed. You can see if head one contains some element, that means it is not reached at the null. So we are directly adding the remaining elements. So head one is pointing to particular location. So all elements which are linking after that, that will directly complete remaining list will be added here. Okay, same for the head two. Okay, and after that we will return a final head pointer for the final updated list. So you will get a final sorted.
Sir, if line 14 is executed, that means line 16 will definitely not be executed, and
Yeah,
vice versa, right?
definitely. Yeah, correct.
Okay.
So either both will not be executed, okay, or maybe one will be executed. Okay, because one of the pointer will definitely complete in this part.
But both will
I
not be
think
executed. That is not
no,
possible, right?
yeah, that is not
Either one
possible.
of the two will always be executed.
Because at least one element will remain in the one of the list.
And how are we dealing with cases if the data is equal? Like if both if say at the second or third pointer,
Still one element will remain in one of the list. Okay, so that means what happens? Suppose if you are getting this type of situation, so 1, 3, 5, 6, 5, 7. Okay, the other side 2, 4, and 6, 8. Both are now this. Okay.
No, I'm
so,
saying let's say 1357 and say 1367 or something like that.
1,
Or
3,
1389, anything. I mean, basically, I want
8,
one
9.
One or two elements to be equal. Then how do we deal with that?
So that will be condition come under the one condition. So under this now, so this one condition you can see if head one dot data is less than head two dot data. If elements are equal, so they will come from this part. Okay, so that means if elements are equal, we are directly taken from the second list element. Okay, or you can do vice versa also. So if elements are that equal, so we will take this element.
So
okay,
we are not having duplicates.
No, we can have this is not given in the problem statement that we don't have the duplicate elements.
No,
Okay,
I'm
we are
sorry.
simply merging.
I'm getting confused here. So let's say we take the second one. So the one at the bottom that we can append to the main list, the returned list.
One. Okay, so
And
now pointer
next
will move to
iteration, so we have to compare between 1 and 3.
Yes, so now this will move. So that means so element will come in the same sorted order, definitely. Okay,
got it. Yeah.
Okay.
I was thinking we'll have to create one more case where if both are equal, we append both or something. But yeah, that's not needed.
No, that is not. We are checking. Otherwise, there is a chance that you have 3-4 duplicating elements. So yeah, you can take this type of condition also, but that will become it will increase the complexity of your code. Okay, so yeah, this is the problem third, and now let's move to the next. Yeah, this is binary search based question. So I hope you remember that we have discussed this in our live coding session. So this is also taken from previous terms OPPE. Because of that, I said that many of the problems are included in the live coding sessions. Okay, so that are also important. So peak in URI model. So here some terminology is given. So this is not a straightforward term in the for the questions. So what is the definition of this peak in UNI model? So that means you have a list and you have one p index in between 0 to n-1. Okay, in between. the value in the array entry is increasing up to this position P. After that, that value will be decreased till the end. Okay, so just find out the to the function peak unimodal that take a list and return the index of the peak element. So what is the meaning of this? Simply you need to figure out the maximum element. Sorry, it's actually crying. Okay, so like what is the scenario we have? What type of list we have? So we have list like this, and is this given like a 1 second. So the sequence of is unit of iterative value are and is increasing up. Okay, so it is increasing, then decreasing. Okay, so we have the sample example. Okay, so now this is the scenario like this. So 1, 2, 3, 4, 5, and then 4, 3, 2, 1, like this. Okay, so now you have the next 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, now this is the point which we are saying that peak in unimodal. So unimodal is given like this. So we are increasing like this and then decreasing. Okay, so this is the graph we can say that, and we need to figure out that what is the index of this peak element. Okay, what is the index of this peak element? So basically we are searching the maximum element in this, but maximum you can directly return like this. So the max of L and then just check the index of that element. Okay, but that will take order of n time, or you can simply find out the maximum element and check the return the index. So that will also a linear operation, so that will take order of n time. But the question is asked for the log n time for this. Okay, so here it is given that write a function for this complexity big O log n. Okay, so that means you need to write a efficient logic for this. And if your problem is asking for the log n solution, definitely you need to think the binary search concept. You can achieve your solution in the log n time, means you have to reduce your work half at the each step. Okay, so that in that way you will complete your problem in the log n steps. So that actually we follow the binary search concept. So that is not the binary search exact implementation. We will use the concept and we will update our logic little bit, and then we will get the solution in log n time. So in this scenario, this is the situation we have. Our elements are increasing, then it is decreasing. Okay, so this scenario we have, and our peak is coming in between 0 and last index. So in this way, how you can do this? So you can simply perform the same middle index, check the middle index every time, find out 0 plus 8, okay, and then throw division by 2 like this. So then you will get an index like 4 and check the 4. Okay, sorry, this is the 4. Okay. So by default, I have taken the middle element as the maximum element here, but there is a 3 possibility here. Okay, so one possibility to find is here actually, if your the peak element. Okay, so just compare your mid element. Okay, so this mid and mid plus 1 and mid minus 1. So only you need to compare all these 3 positions every time. So first figure out the mid position, just take mid plus 1 also and mid minus 1 also. Okay, then check if mid element is smaller than this or greater than this. This is fine. No, this one, sorry, greater than your right element or greater than of your left element. Okay, if your mid element is greater than the both neighbor elements, so that means this is the peak element, maximum element of your list. Okay, because our structure is like this. Okay, so if you have reached at this point, so that means you will get a smaller element this side, smaller element this side. This is the one condition. If you are getting this true, return directly this index as an answer. Otherwise, maybe you will reach at this side. Okay, so this is the down, like increasing, okay, increasing dimension, and this is the decreasing dimension. Okay, so if your mid index is coming at this line, okay, so that means what pattern you will get for these 3 elements. So you will get a pattern like this. So mid is smaller than the that mid plus 1 and is greater than the mid minus 1. Okay, so you will get this pattern if your mid is coming at this side. Okay, so when elements are increasing. So if you are getting this pattern true, so that means your peak will always come to this side. That means peak cannot be come to this side. You can directly ignore all these things, all remaining things completely. Okay, because elements are increasing this side, so definitely peak will come only this side. So in the next iteration you can do, you can directly take your list size from this position to the next last position. Okay, and remove the half part. Same things if your midpoint is lying in this range when elements are decreasing, so your this condition will be true. So that means mid element will be that that is smaller than. Okay, so smaller than your mid minus 1 and greater than your mid plus 1. Okay, so that means elements are decreasing in this way. So that means your mid is coming on this line. Okay, so in that case you have to ignore the right side and you have to take in the left for the next iteration. Okay, you can remove the half part of your right side if this condition is true. So that means the same binary logic we are using, and in the each steps after calculating the mid index we will check these three conditions. First condition is this: if this is true, return the mid index as a answer. If this is true, then ignore the left half part. Okay, if this condition is true, ignore the right half part. Okay, so only these conditions are required. Just run a binary search type of loop and you will get an answer in the log n steps. Okay, so every time you will remove a half part of the problem. So I hope this part is clear, and we have discussed these problems in the week either week 2 or week 8 when we have discussed this divide and conquer, or maybe in the binary search. So anyone have written the solution for this? No one. Okay. Amrita is asking, please tell me which are the important
Sir, should I share it there?
Yes, someone is Dev is shared.
Okay.
Okay, so let me discuss. So first thing, you can see this code. So okay, so this it is not taking all the conditions. Yeah, maybe you will get the solution in this condition also. Yeah, okay. So while first is less than equal to last, this is the okay, and we are calculating the mid index first. After that, we are checking if nums of the mid element is greater than the mid plus 1. Okay, so that means our elements are decreasing. Then we will set our last equal to mid. Else we will set our first equal to mid plus 1. Okay. So okay. Yeah. So this is also correct. In this way, we will reach at the mid element actually. So after so if this condition is true, then we will repeat the process, and at the end when this condition is become false, so this first will actually reach at the peak element. Okay, so this is also true. Otherwise, to understand better, so these are the three conditions is actually you can follow for this, or this is the short logic that will also
Sir,
return
I
the correct.
posted the way you discussed.
Okay, that I'll also check. So first test this also. And one more important thing, if person is asking the log n complexity based thing implementation, so do not use slicing, okay? Because one implementation is also given with the slicing, okay? But do not use that. That is actually order of n operations internally, so it will increase your complexity. Only write your that without slicing code, or also try simple iterative code. So yeah, this is working. Yeah, this is working fine. And see, we can see this. So you can see the same logic. So we are setting our low to 0 and high to last index. After that, we are setting this, checking this condition and calculating the mid index. And then we are writing this, check if mid element is a peak. Okay, so this is the same condition, return answer. Otherwise, if this is the constraint, if our any side index is not equal to that the corner elements. Okay, so if our mid is greater than 0, and we are checking this. Okay, so if elements are now decreasing right to left, that left to right, so then we are setting our high to mid minus 1, otherwise low to mid minus 1. Yeah, this is okay, also same. So this is the implementation. Just keep this thing in mind. Do not use slicing in this topic. Okay, and also just keep the while loop based code. Okay, do not use recursive based code, because in the recursive code also you can try only that variable based code, where you have to set the index inside, you have to set the index or inside the variable. Okay, do not pass the slice list. Okay, that will increase the complexity. Yeah, so this is a solution for this. So you can just practice this type of questions where binary search can be applied. Okay, so next is this PF5. Okay, yeah, so the graph based problems, yeah, this is little bit tricky problems. Okay, and otherwise in the graph problem, definitely one problem will come from the graph week 4 week 5. So as I mentioned that you can learn a shortest path algorithm, at least one. Okay, you can learn any one of the minimum spanning tree algorithm. So this is the B, this is from the week 5, only 2 algorithm you can learn. Okay, from week 4 you can learn that DFS one algorithm. Okay, and also check the that another related algorithms where we are finding out the components. Okay, that number of components, this type of things. And another is actually topological sort problems. Okay, so where the topological sort also have 2 algorithms that are actually dependent. So that that precedence, that not precedence, the prerequisite dependency based problems can be asked on the topological sort problems. So that 4-5 algorithms are required to learn in the that graph part. And most of the time straightforward question is asked actually. Okay, so sometimes if any small logic is required, so otherwise the straightforward algorithms you need to write to find out the solution. So some spanning tree based or some BFS traversing based, number of component, like this, so you can remember this. Okay, so an easy algorithm which you find easy, you can just remember in this week. Otherwise the remaining problem, definitely no need to remember any code, you have to apply your logic at the time. Only this graph based problems you have to remember any algorithms, so to write the code.
The graph problems, like in all you're telling that topological sorting, likes just like it's
So in week 5 we have 3 shortest path algorithm. Okay, so the Dasht algorithm, Bellman-Ford algorithm, and Flood-Warshall algorithm. So if you want to learn any one algorithm for the OPP, so I think Bellman-Ford is the easiest one. So most of the students, we have figured out that they write the Bellman-Ford algorithm if any question asked for them. Okay, because it is easy to remember, only that some that iteration are required. So generally we not test the complexity for graph based questions. Okay, so you can use any algorithm. Dashed algorithm, if the concept is clear, algorithm is very clear, so you can also remember the dashed algorithm. But any one algorithm should you should learn for the OPP exam.
So
Okay,
they won't
and
consider
the one is enough, sir.
sorry, can you repeat?
So they won't consider the complexity for graph problems.
Not not required, compared. Okay, so complexity is only compared when the naive approach contains the very high complexity and efficient solution have the very less solution. Okay, if very less difference is there, so it cannot be tested actually. Okay, so like suppose if you have n solution and n log n solution, so that is actually not compared, that cannot be compared on the system. But if we have one solution n and we have one solution log n, so this is actually very high difference is there for the large data. So it can be tested, it can be compared easily. Okay, so like n square and n log n, this type of solution can be easily compared. but the closer solution that cannot be compared. So in generally that graph problems or any dynamic programming problems or that EDD problems, generally we not ask the complexity.
So for shortest path, BFS is
No, BFS
or
BFS is shortest path. BFS algorithm is not there if the weights are given. Okay, yeah, that is required. BFS is required to check the connectivity. Okay, so this is the one application, check the connectivity, all nodes are connected or not, and with the help of connectivity you can figure out the number of connected component. Okay, so how many connected components are there if graph is completely not connected. Okay, so maybe some 2-3 connected components are there, so you can just figure out the number of connected components. Yeah, if graph have only the edge and we want to find out the shortest path in the terms of edge in between the path, or in the terms of number of vertices in the path. Okay, so in this way we can figure out the shortest path using the BFS algorithm. If shortest path is asked for the weights, like the weights are given on the edge and that weights are actually different, okay, distinct.
actually I'm asking for if BFS is enough for the shortest path, or I have to check again with the BFS.
First things, your voice is not clear, which what I am getting, you are saying that BFS is not.
I have to go through the two BFS and DFS, or I just go through only BFS.
No, so actually both algorithm BFS and DFS, these are traversing algorithm, not the shortest path algorithm first. Okay.
Yes. So
okay, so
that's upon our wish, right? Which we are
so you can use BFS if any connected component question is asked. So you can also use the BFS or DFS. This is up to you. But most of the time BFS is more important. Okay, so that also do the all things for the DF, which DFS actually can do. So you can also check the cycles using the BFS, all these things. Okay, so you can learn any one of the algorithm like BFS you can do. Okay, so BFS applications are more like you can also use for the shortest path in the terms of number of edges in the path or number of vertices in the path. So that is also one application for the BFS. So some real life scenario question will be asked. Okay, so some story will be given. Okay, you need to just figure out that what type of that what they are asking actually in the terms of a story. So if they are asking connected component, if they are asking the that what minimum number of semesters are required, that if you follow this precedence, if you that one DAG is given to you, so you need to just get the main that required things from the story, and after that apply the algorithms. Okay, which algorithm is actually best suitable for this.
we also learn the sort algorithm.
Sort algorithm.
All sorting algorithms.
Sorting algorithm, as I mentioned, that we have performed one sorting on the that linked list using the merge sort, that concept. Okay, but what happened, we generally not ask the simple sort questions. Okay, sort based question, where you can also use this Python sort, simply dot sort like this. Okay, so that generally we not ask straightforward this type of question. Yeah, sort based question can be asked, but with some other task will also be given. Okay, so maybe you need sorting to perform the other operation. Okay, so you can directly use your that Python sort. Okay, dot sort. After that, you need to perform other things.
Sir, one doubt in this. So you are saying that we can follow the other algorithm for the shortest path, but in this problem, given it is that Dijkstra's algorithm is already given the code. If you want to implement some other thing, then whole code you have to write, right?
Yes, whole code you have to write. Yeah. So yeah, that is fine, because here already algorithm is giving. So this type of problem, this is actually not a straightforward problem. Okay, so straightforward means when your that problem will be solved directly any one of the algorithm, which is you have learned like dash algorithm, or straightforward like you need to just find out the shortest path. You need to find out the new spanning tree, like this type of problem. You can directly write the algorithm. In that case, you have to write the complete algorithm by your own. Here some additional task is required. Okay, at the top of that algorithm. So that means you need this algorithm, but you need other activity also apart from this. Okay, but you have the time limitation in the OPPE exam. You can not write this algorithm as well as the other logic. So in this type of problems, actually some supportive code will be given to you. Okay, if any additional task is required, then supportive code will be given to you. You can use that code and write your additional logic. Okay, so otherwise, if problem is straightforward, that can be solved only this shortest path algorithm. In that case, this algorithm code will not be given. You have to write the code, this algorithm. Okay, so because of that, I'm saying just remember at least one shortest path algorithm, one spanning tree algorithm, and BFS algorithm, and one topological sort algorithms. So then you can directly apply if the problems comes straightforward. Okay, and practice on the similar question also, which we have given in that weekly assignment or live coding session. So yeah, so this problem is what is giving asking that.
Actually, you are telling the whole syllabus itself.
No, in the week, as I mentioned, that week 4 and week 5, yeah, definitely algorithm is required. For other remaining problems, no need to remember any code. You have to apply the code. Okay, just solve, practice with problem. You that remember will not help any. Okay? That you cannot remember any code and you can directly write the code. Other problem will be solved by your own logic. Here is for the graph-based problem, you need the algorithm actually. Okay, so just remember these algorithm. Otherwise, the practice is required.
Sure.
So yeah, so that problem number 5. Yeah, shortest circular route. So in this problem, what is it is given that we have this W list. Okay, so this is the data given as a adjacency list form. Okay, where we have the key, each key contain the like the source index and the destination index with distance. Okay, in the list of tuples. So we have this data and we have one source node. Now we need to figure out that shortest circular route in the graph. Okay, so what is the meaning of this? Okay, so actually rule is two-way list pattern. So the function return the total distance of the shortest circular route from city S. Okay, and shortest circular route means you cannot repeat the name that elements in the path. Also, that a circular route from S consists of a road from S to a neighbors U followed by a path back to U to S. Okay, that does not use the road US. So if you are going from that S to U, you cannot come from U to S again. Okay, you have to come from any another path. So that means you cannot use the same S again in your path. So this circular path is asked, but the total distance should be minimum in this case. Okay, and when that note is given, you are guaranteed that there is always at least one circular route. Okay, so this is one given. Okay, now the problem is like we can take one graph and we can understand this. Or I'm taking randomly. Okay, so what is actually given here? So we have one S node. Okay, suppose this can. Hello.
Sir, instead of Dijkstra, I used Floyd Warshall. It was actually easy.
And that is working.
Yeah, because we can find the route, right? We can find the circular routes also in Floyd Warshall.
Okay. Circular route. Yeah, S to S. Okay, that you are saying. If that is working or not here? Have you tested?
So actually I didn't try it, but I think it will work because I remember one of the questions was like that in one of the GRPAs where we had to return if there were negative cycles or not. And I used Floyd Warshall in that question and it worked.
Okay. Yeah, you can try it. I haven't tried actually. So
yeah,
if it is returning the shortest path that way, because yeah, in the matrix, final matrix, we have the thing. So S to S, you need to figure out that part when you're getting at S to S. okay, in the row and column combination. So if it is working, so that will okay, fine. Otherwise, what we can do, suppose we have this source, okay, in the graph. This contains some three adjacent vertices. We have like this v1, v2, v3, okay, some weights, and like so this is 5, this is 2, this is 1, and after that we have another part, okay. So it's like we have another node v4, okay, and v5, and like this v6, and we have this v7, and this contain directly here. It's like this. Yes. Okay, so it may be anything. So like this contain here, and the weights are like this. So this is 2, this is 8, this is 5, this is 1, this is 6, this is 3. Okay. So what we can do, we have this type of graph. We want to find out the shortest circular path from S to S. Okay, but that cannot be repeat the edge in the path. And now we have multiple paths here this time. So we can write like this. So S to that V2, sorry V3, then V4, and then V2. Okay, and then S. Okay, so this is one possible path, and we can come through this path like so that S, then V3, then V4, okay, then V5, and then V5 to V1, okay, so V1 and then S. So in this way we have multiple paths are there, and that not repeat the actually edge, any edge, and among all these possible paths, which path contains the shortest distance? So that we need to return here. Okay, so this is the problem statement. So among all possible paths, so there are a lot of possibility here. Okay, so you can come from any possible path. Okay, so which contain the shortest path? So how you can do this? Here, Dijkstra algorithm is given to you. Okay, so yeah, any logic? So I hope many of you have already done this. So just can anyone explain the logic for this? Yeah, one have mentioned that Floyd Warsaw. So I'm not sure about that. That will calculate the shortest. Yeah, it should calculate it actually for the positive weight graph. Okay, that will work maybe. Otherwise, if Dijkstra algorithm is given, then how you can use this Dijkstra algorithm here, and you can figure out the solution. So any approach, anyone? What you can do here?
So I went through some previous session. Same problem was there. Got the solution like this, but I myself did not understand some places they're using this. They hard coded because here in the given problem that the source is S, but that is 0, and then the other side the end node is 1. So they're using in the each adjacent one, and then removing the each adjacent one. This is something I did not understand, but otherwise
okay.
Okay.
So logic is not clear completely, you are
Yes,
saying?
yes.
Okay. Yeah, that's thing we will try here. So okay, so I'll discuss this. So what we will do, how we can figure out the path here. Okay, so because okay, so yes, yeah, Dijkstra algorithm actually calculate the shortest, that is actually single shortest path algorithm. So that calculate the shortest path from S to all the remaining nodes. Okay, so this is the source and others are destination. So how we can use Dijkstra algorithm here? So what we will do, because here S2 we want to find out, suppose we have 3 adjacent, so that means if we are going from any one adjacent, we cannot come from this adjacent. Okay, so we have to come on the same source node from the another adjacent. We can come from the another adjacent. So what we can do, we can figure out all the adjacent nodes. So that means we have 3 adjacent nodes for this graph. Okay, so V1, V1 we have, V2 we have, V3 we have. Okay, 3 adjacent. So if we are going from this V1 S to V1, okay, so S to V1, then we can only come through V2 to S, okay, or V3 to S. Okay, so that means we can going through any nodes. Okay, so if we are going through this VS to V2, then we cannot come from this V2, okay, in the circular path. We have to come from another adjacent, so that we can test it this from every adjacent vertices. Okay, then we will figure out that which one is the shortest circular path. So what we can do, we can pick all the adjacent of this S, and we will consider this as a source node. Okay, we'll consider this as a source node, and what is the edge we have from S to V1, that we will keep. Okay, so here you can see for the V1 we have this 5. Okay, so this S to V1, that we will contain as a 5. Now after keeping this value as a 5, we know that S to V1 we have this 5 distance. What we will do, we will remove this edge from the graph. Okay, so S to V1, this edge we will remove from the graph. Okay, so graph is given as a adjacency list, so that means we will remove this from the adjacency list. Now that means suppose if we have removed this, okay, so just not consider this in the graph. No, sorry, not this, this one. Okay, S to V1, this fiber. So after removing this, if you apply the, consider this V1 as a source, okay, this as a source node for the Dirichlet algorithm, and call the Dirichlet algorithm, consider this as a source. So what Dirichlet algorithm will do, Dirichlet algorithm will return a shortest distance for each destination vertices. Okay, each vertices which are remaining from this. So that means now we have removed this S to V1. So that means Dirichlet algorithm will not consider this as a shortest path. Okay, so definitely it will consider another path to reach at the S. Okay, either from V2 or either from V3. So, but Dirichlet algorithm will definitely will return a shortest path distance. So you can call the Dirichlet algorithm on V1 and check what shortest distance you are getting for S. Okay, so this is means V1 to S, what value you are getting. Okay, suppose this is X. Okay, now this is the one possibility. Same apply here, and after performing this operation, again add the edge. Okay, so that means for the next time we need this edge when we are just considering this V2 as a source. Okay, then we are considering that S to V2, this we will keep. Okay, we will store this result as a 1, but then we will remove this edge, and we will call the Dirichlet algorithm on V2. Okay, so V2, this Dirichlet algorithm will return a shortest path from V2 to S, but will not consider this as, because we have removed this as. So now V2 to S, suppose this is returns. Yes.
So sir, we are saying the edges means the weight of the edge, right, sir?
Adjacent means which are directly connected from S.
No, sir. We are saving. We are memorizing the edge.
So that
like
weight, yeah, weight,
of
correctly weight. That weights
not
we
the
will
points,
add,
not the like topple from this to this, like not like this.
No. So we are just storing this edge weight. So this S to V1, what S to V1 we have? V1 have this 5, okay, and we will remove this edge. After keeping this 5, we will remove this edge. Then we will find out the shortest path from V1, okay, to S. So suppose you are getting this X, then for circular path we will add this 5. Okay, X plus 5. So this is the total circular path distance. Okay, so that means S to V1, and then V1 from other path, then you are coming to S. So this distance is 5 and this is X. Okay, so this we are calculating, and okay, this we are calculating from Dirichlet algorithm after removing this edge. If we will not remove this edge, your Dirichlet algorithm will directly contain the shortest path, reverse back. Okay, that we don't want to, that we can not do. We need a circular path which are actually where we can come from any another vertex to S. We cannot come through this V1. Okay, so that is not the case. Same things we will do from V2. So now S to V2 we have this 1. Okay, so that means we will keep this 1, and after that we will remove this edge. Then we will call the digest algorithm on V2. So now our digest algorithm will return a shortest path from V2 to S by any another path. Okay, without using this S to V1 edge. Okay, so in this case, this will return a shortest path distance. Suppose this is Y. Now we will add this for the complete circular path distance. We will add this one, okay, which we have removed. So this is now total shortest circular distance by this. Okay, and another is this remaining. So this is S2 V3. So this is now 2. Okay, and now we will remove this 2, and then we will call the rest algorithm on V3, and we will check the shortest path distance on S. So that means V3 to S. Okay, suppose this is Z, and we will add this to here. So now these three possibilities are there. So if we are going this V1 and coming from another vertex, okay, same we are going through V2 and coming from another vertex, and going through this V3 and coming from another vertex. So now three possibility, three shortest path, circular path we are getting, and among all these circular path possibility, we will return a minimum. X plus 5, Y plus 1, and Z plus 2, and we will return a minimum. So this is the logic for this. So you need to just what is your task here? First thing, find out the adjacent of S. Okay, and for each adjacent, do this task. Okay, for each adjacent, just keep the adjacent weights in some variable and remove the edge data completely from your adjacency list, and then call the digest algorithm on V1 and pass the updated data adjacency list. Then your digest algorithm will return a shortest distance. Just read that and find out the this circular shortest. Okay. So in this way, just repeat this process for each adjacent weights. And after getting each, then just perform a minimum among all. So that will become a shortest circular path, okay, among all circular path. So this is the logic for this. So digest algorithm is giving. Now here the main task is this, just removing the data from the adjacency list and call the function, and then again add this data. Okay. For next time we need the our original list. So I hope someone have sent this also. So I'm copying this.
So this kind of this looks a bit complex. Whether this kind of
so this is, as I mentioned, that this is a little bit tricky, and it is asked in the initial terms actually, and we found that this is tricky question. So in generally we not give this type of tricky questions now. Okay, so let me show you this solution. So you can see what we are doing in this solution. Let me check this is working or not. This is working. Okay. So it is sent by Vivek. Yeah, Vivek, are you in meeting?
Yes, sir.
So can you just quickly explain your code? I think if you have mentioned that, you know that very well. Okay. So can you just explain your line by line what you are doing?
So first I initialize the minimum distance as infinity.
Okay.
Then I iterated the loop for the length of a dictionary that many times.
Okay, so
then
this is one
I
second.
took
Yeah,
the
so for I in range, len of W list S. Okay, so this you are doing for S. Okay, so S.
for the
Okay, so these
source.
are adjacent. Okay, adjacent. Okay, yeah, that's fine. So this
Then
S is actually contained the adjacent node, and you are reading all the nodes VD. Okay,
yes,
fine. Yeah, yeah, please.
and so VD is the edge of the neighbor with the
Okay.
source. Then I removed the edge from V to S and S to V.
Okay, fine.
Calculate the distance from V to all the in the tree.
Okay.
Then again added both the edges which I removed first,
Mm-hmm.
and then
Okay.
the minimum of the infinity and the recently calculated distance.
Yeah, nice. This is very clear solution. Okay, so what we are doing, we are reading all the adjacent because this S is the key. Then the value will be the connected nodes. Okay, so that we are reading the all nodes, so that V is the adjacent. Okay, so this V means the adjacent vertices, and this is the distance for that. Okay, so we are reading this for each I of the that adjacent. After that, what we are doing for this V, that means S to V. This is the one adjacent. We are removing S to V this edge, so we have to remove from the both side. Okay, so that means we have the edge, that is S to V, and we have also one record V to S, because the same as this is the undirected. Okay, so this, that means we have two entry for, in our dictionary for that, S to V or V to S. So that means we have to remove both entry. Then after removing this both entry from the linked list, we are calling the digest algorithm and passing this updated W list with V as a source. Then we will get the distance dictionary for this. And you can see after performing, after calling this digest algorithm, then we are appending the both that removed information, okay, for the next iteration. So now we have appended this the same as we have appended, okay, both entry. Now we got one that result for the data call. Then we are just checking that we are comparing our previous min distance and the current min distance we are getting from the data call. So that is actually, we are finding out the minimum from min dist and D. Okay, so D is the this weight, okay, which we actually remove D, and distance of S. So this distance of S is representing from V. So because V was the source for this call. Now, out of this, which one is the minimum? Then we will do the same things for the second adjacent, then third adjacent, and we will check the minimum amount. And then we will return the minimum distance finally. So this will be the shortest circular route distance among all the circular route. So this is a straightforward, clean solution. I hope this is clear.
Yes, sir.
Okay. And okay, so this is week 5. Now weeks the problem 6. Okay. Start loading. Yes, great. And why we PPA? Yeah, this is loaded now. So here this is binary search operation based problem. So here what is given? Binary search, some class is given, and this class contain these three things. So init this class node. Okay, node is given, the class node is given, and this node contain this field. Okay, so that means left, or this is self dot left, self dot data, and right. Okay, so each node contain these three field: left reference for right child, left for left child, and data. Now you have to perform this function insert element. So this is simple binary insertion operation is there. So that means root element is given, root node is given, and the value will be given to you. Okay. You need to just insert a new node in this binary search, that binary tree, sorry, binary search tree. So after that, you need to perform this insert operation, and the remaining part will be done by the suffix code here. So this, you can see some is there, so that class is given and this function definition is given. So here the remaining code is hidden actually. Okay, so just do your task only, do not print anything or do anything. So just after inserting all the elements at the correctly, that suffix hidden code will be traverse the list either by in order. So here list is traversed, tree is traversed by all three, okay, in order, pre-order and post order. If your tree is correctly created, then you will get a one fixed answer for this. So
only we have to insert an element.
you need to just insert the element. You need to complete this function only. Okay, no need to return or print anything. Okay, so the
sir,
remaining part will.
in this we just need to do the binary search and insert the element.
So you need to simply figure out that. So this is actually very similar to your linked listings. Okay, so first thing you should know how the binary search tree created. Okay, so suppose if you have what are the process for that? So suppose if you have empty that binary search tree, so that means root is contained none in that case. Okay, so none like this. So root, we have the variable for the root node of the binary search tree. This is none. That means no node is there. So what is the meaning of this? Now we are getting elements in the one by one. Okay, so like 10, 5, then 20, then 8, then 3, then 1, like this. So what we will do? That means your function is called. Then in the function called, then first thing you will check if root equal to none. Okay, if this condition is true, just add this node. Okay, so that means what you will do, you will just you will create a node first. Okay, so you will create a node. So node, and just pass this value 10. So what will happen? One new node will be created, and that contains 3 field now. So this 10 will be stored here. Now this will become a none. Okay, because this is the first node. By default, if you are calling the class, so that will be filled by none, and your root will be linked to this. This is the first. So you can see the definition of this. You can see both values initialized by none by default. Okay, and this data is initialized by data. If you're calling this, creating the object with the data. Okay, so that is the by default things. And so this is the first step. Check this condition as a first for the if root is none. After that, if you're getting this second element like 5, and your root is not none, so this is the else part for this. So in that case, so just compare this. I'm just creating the simple binary search tree now. So for the binary search insertion, always start comparison from the root node. Okay, and just check, compare the element. If that element is smaller, then move to the left side. If this new element is the greater to the current element, just move to the right side. If when you're moving to the left or right, if the next element position is not none, okay, if it is not none, that means you have the one more element on the left or right side. So that means repeat the same process again. Okay, just compare the element from the left or right and just move accordingly. Okay, so here if we are inserting this 5, we will compare from this 10. This is smaller, so we will move to the left side, and left side is none. Okay, of this 10. So that means if this is none, create a new node. Create a new node and connect, insert here this. Okay, so this is 5. Okay, so now this will be add here. Now next is 20. So same things, start from the root node. Okay, so 20 is greater than 10 and right is empty, none. So insert a new node here. Okay, so this will add here 20 in the next step. Now the again function will be called with this 8. So we will start from the root. So 8 is less than 10, but left is not none. So we will repeat the comparison on the left side. So now 8 is greater than 5. Yeah, we will move to the right of this 5. So we will check if this is none or not. Yeah, this is none. Our right field is empty. So we will insert a new node at here. Okay. Now 3. So same things. 3 is smaller than 10. Move to left. Smaller than 5. Move to left. So this is empty place. We will insert here. So same for 1. So now 1 is smaller than 10. 5, 3, 1. So it will insert here. Okay, so just link correctly according to this comparison. So always start the comparison from the root. Okay, and add the place when you're getting the empty place. So this one will be insert here. So your task is just to insert in this way. After that, now this is also similar to the linked list. You are simply connecting the reference, and this will be traversed by some algorithm, that in order, pre-order, post-order. This tree will be traversed by this algorithm, and that will be printed in some order. So that your task is just to insert here. So this is the process to insert. Now correctly reference the things. Okay. So yeah, this is the task for this problem. I hope you can do this, because this is very similar to the linked list. Okay, so, and if you remember that we have this algorithm in our notes also, so all binary search operations, so you can do it. And so what are the other possible questions for this? Okay, so that we will discuss once. First thing is searching. So searching will also follow the same concept. So one second. So this is binary search tree. Binary search tree. So you can see in this we have this find insert. Okay, so this is the simple code. Okay, so you can just see this algorithm, and this implementation. Yeah, this is given here. Or you can write your own implementation. Okay, so this is maybe a recursive algorithm is given. Yeah, same algorithm, but we have that implementation that is actually a different. Okay, where the node class is different. Here everything is actually in the same class, but the concept will be same. If this self dot is empty, actually we will add as a first node. Otherwise, yeah, if we are adding the same element, because in binary search tree we cannot add the same element 2 times. Okay, the all elements should be distinct. So if we are getting the same element, if our value is matched, actually, then we will return back without inserting. If our new element is smaller than, then we will call recursively on the same algorithm on the left child and return. If our element is greater than to the current element, then we will move to the right child and call the same insert algorithm. Okay, so in this way you can do this solution. Okay, so that binary search based. What are the other possibility for this is just find out the maximum element. Okay, so just find out the maximum element. If you have the root element of the binary search tree, just find out the maximum element of that. So what you can do, you can traverse all the right element. Okay, so that means just repeatedly traverse all the right element. Okay, because the maximum element always comes at the right most child. So what you can do, you can just check if right is there of 10, just move to the right. If the right is there, then move to the right. In this way, you can repeatedly perform this and reach at the end of the rightmost. That will be the maximum. Same things if you want to find out the minimum element on this. So just read the all left child. Okay, so left child, left child. If you find out the none empty, then just stop that and return the answer. So that will be the minimum element in this. Searching operation is the same as insertion. Okay, just compare the element and check if at any time if the element is matched, searching element, you can stop and return yes, answer that element is exist, like this. So this type of operation you can perform. So all the basic operation is given the implementation in this notes you can see. So like this find element, searching out the minimum value, that maximum value, you can see this type of implementation you can do, recursive implementation. Okay, if it is not empty, it is empty, then return the answer, otherwise move to the left, like this. Insert, okay, and delete. Okay, so this is the main basic operation of the binary search tree. So you can just look this also. So this is one problem. I hope you can try this. I'm moving to the next. Yeah. Now this is the dynamic programming based. So last two problems we have the dynamic programming based questions. So PPA 7 and PPA 8.
So
yes.
Sir, I have a doubt. How to classify the problems, like if it is greedy or dynamic programming?
Yeah, so that regarding the dynamic programming, first thing, you have good practice on the many number of problems on the dynamic programming. Okay, and after that, that means what you can think, if just think that for the small input. Okay, for sample input, you can see some sample input is given in the problem itself, and some explanation is also given. You can think that solution can be achieved by some that specific strategy, like just sort the things and perform the some specific task and just get the answer, or your solution will be achieved from the you have to check the all possibility of the combinations, like, okay.
Actually,
So
recursion is main part of dynamic programming. Without it, we can't code.
sorry.
For dynamic programming, recursion is a main part.
Recursion is the main part. That means by the recursion also you are actually exploring each possibility. Okay, so recursive approach also you are actually checking the each possibility. Okay, by the recursive approach. That means your answer, to find out the answer, you have to check the each possibility. Okay, then you can figure out the answer. So in that case, to checking for the each possibility, you can do this task by smartly using the dynamic approach. Okay, so that is actually the approach is simple. You can start from the smaller problem. So then you can start from the that bottom to top manner and start from the that initial part and just store the solution of each part. Okay, and at any time if you are need that previous solution, so do not perform computing again that part and just use the solution directly. So in this way,
DP takes less time than recursive function, recursive programming, I think.
no, recursive is also fine. Recursive approach you can also try. If you are getting your solution recursive approach, you can also try. Okay, in that question also we are not stopping anything. We are also not testing the complexity. Yeah. So if you feel that, yeah, that means by recursive approach, that means you can achieve the solution, you can try. So that is the one thing. But how you can convert that recursive approach to the dynamic programming, that is the different things. So that actually make the efficient. But yeah, in the constraint of the timed assignment, if you are thinking that your recursive approach is very clear, you can try quickly, then yeah, that will be fine. You can also try that. Okay, recursive approach. Otherwise, you have seen many example like this LCS, all these things. So you can see LCS problems or this LCW problems. What we are doing, you cannot touch directly calculate the answer because let me just open that one example. So dynamic programming. So LCS, LCW. Okay. So here you can see you have two strings. Okay, so the one strings and second strings, and you need to find out the longest common word, continuous word. So that means that word can be come from any position to any other position in the from the first list, sorry, first string, and that can be matched into the second string from any index to any another index. Okay, that means here you have to find out the, you have to check each possibility here. You cannot figure out the result by just looking any one specific statistic way. Okay, so that means this SEC can be matched from any index from 0 to 2 or 1 to 3 or 2 to this, like this. Okay, and also you have the another possibility from the first string. So like this, suppose this SEC is not the longest, maybe ECRT is the longest, so that can be matched. Okay, so in this way you have to check each possibility of the, for the checking you have to check the each combinations. So but how you will check this each combination, that is some smart way. Okay, so that is actually we are performing using the dynamic programming in the smart way. We are starting from the smaller problem. Okay, a smaller problem, that means the one string is empty, another is also empty, so we are making this as a bottom base condition. Okay, so that means zero matching. Then we will store the result of this, and we will increase the problem size, and then we will use the previous solution to find out the solution of the next size level. So that type of problems where you feel that your solution cannot be come without checking all the possible combination, in that case you can think about this dynamic programming or recursive approach. Recursive is also doing the same thing. So recursive calls means that we are checking the each we are then expanding our calls. Actually that call is expanding to the 2 to the power some things like. Okay, so that we have seen this Fibonacci series example. Okay, So Fibonacci series is expanding for the each possibility. Okay, so that fib 5, then fib 4, fib 3, then we are getting the solution. Then again we are expanding these things. So same way you can do this recursive approach for the another problems also for the each possibility. Okay, so that what is the possibility like this? Suppose you have this one list. Okay, so 3, 4, 6, 5, 8 like this. So suppose if you are looking the answer that you have some value like 20. So what is the combination of element you can achieve this like this? Okay, so I'm just giving one random example. So that you have to check the combination of elements. Okay, so that means 3 plus 4 maybe you will get answer, 4 plus 6 maybe you will get answer like this. Okay, so in this way what you can do, you can just call the function like this. So recursive call, and suppose this is the solution, and you can just pass one element 3 and with this next element. Okay, so like 4. So this is the one call. So there are the two possibilities like from the first position. Okay, so when you are calling from this sol 3, okay, then you will include one. Okay, so include 4, that sol, that include this 3 comma 4, and the next another part not include this. Okay, so sol, that means not include this 3 and just move to the next like 6. Okay, then further that the same way, that means with 3 we are checking that the answer with including this 4 or without including this 4. So that means we will call the on the same direction. Now our each call will do these things. Okay, so for from the next part without including, then we will include the next element, or without not including this element. So that means by recursive call also we are checking the each combination. Okay, so in this way we are expanding the our recursive calls to the multiple recursive call and that recursive part is actually doing the same things. Okay, it is checking the each combinations to getting the result, but the same things we can do this the dynamic programming also. So you can just what you can do for that type of problem, just take some that problem, that sample input, and take the small part of that and see uh, is there any way to get the answer for small part, how you can get the answer for the small part, and then how you can use the solution for the small part to achieve the solution of the bigger part of the problem. So that is the main part. And yeah, dynamic programming is not very easy. So generally in the exam we also give one we generally not give this two-dimensional type of problems, okay, where the tabular form is required. Maybe one-dimensional array, or you can achieve the solution. So okay, so that problem will be, yeah, so just practice on these all problems which we have mentioned in the live coding session, assignments, or this problem here. So that will give you the sense of the dynamic programming. Otherwise you can try to another approach also. Okay, this recursive approach also. So okay, so the next column is week 7. Yeah, this is also a one. You can see here something is mentioned in the top. So this Indian National Olympiad in Informatics 2008. Okay, so this is just some competitions. So that Professor Madhavan sir actually involved in this. So that problem is taken from that competition. So yeah, this is problem is asked also in the first term. Okay, this is also the tricky problem. So here what is the question actually, and how it can be solved using that dynamic programming. So the what question is given actually, you have this 2 rows and many columns. Okay, okay, so for the as a input, and each square in the grid contains the integer. So that means each contains the value. You are given a supply of rectangle 2 by 1 tiles. Okay, so that means what you can do, you can make it tiles. Okay, so make it tile either by just one column, or the as a, in the horizontal manner 2 elements. Okay, like you can make a tile as a rectangle by of size 2 by 1. Okay, or 1 by 2, like in this way. So each of which exactly cover 2 adjacent squares of the grid. You have to place tiles to cover all the squares. So that means you just divide this complete grid pattern into the tiles, okay, of the two elements, like this way. Okay, and after that get the total score for each combination of tiles like this. Okay, so for tiling 1, tiling 1, you can see this example. So here we are taking 8 9 6 2 7 1 and 3 2, these 4 combination. And in this combination we will always, from the each tile we will find out the absolute difference. Okay, so that means the difference from maximum to minimum. So what difference we are getting? So 9 minus 8, 6 minus 2, and 7 minus 1, and 3 minus 2. For each difference, we will add the solution and then we will get the score. Okay. So there are multiple possible way here actually. Okay. So you can just make this grid in the different type of tiles. Okay. So tiling 1 and tiling 2, two example is given here. Okay. So if we are dividing our grid as a tiling 1, we are getting the score 12. If we are making the tiles in the different way, then we are getting score 6. So there are multiple way we have. Okay. And here you can see we cannot achieve the answer without checking the all combination. Okay, because here there are multiple possibility to make these tiles. Okay, so 8 6 we can achieve, then we can take horizontally, we can take vertically like this, and we can make the multiple way of to taking these tiles. So we have to check each possibility. So that means we can, to get the answer we have to check each possibility. So this is the question now. Now how we can solve this? So solution hint is given. So recursively find the best tiling from left to right. You can start the tiling with 1 vertical tile or 2 horizontal tiles. So use dynamic programming to evaluate. So yes, some hint is given for this problem also. Okay. So what this hint is actually. So okay, so let me just take one snapshot for this. So now this is the this data we have, like, okay. So what we can do, okay. So suppose this is the index 0 1 2 3. Okay, we have two lists like A and B. Okay, the input is given like this two list. Okay, and we have the same element, we have the corresponding G index. Now what we can do, we can take one more index, and this is just a empty. Okay, and we are considering that there's no element. So the solution for this is actually, we are taking like as a 0 0, so we will get a solution as a 0. Okay, after that, so this we are making as a base case. Okay, this we are making as a base case. Suppose we have the smaller problem, only this 0 0, then the final solution for this is actually 0. So we are making this as a 4th index and we are getting this answer. After that, what we will do, we will increase the size of problem. So we will increase, so and our goal is to find out the minimum score, or minimum or maximum. So sorry, let me check. What is this? The score for the difference is bigger element than maximize. Okay, so maximize the score. Okay, so maximize the score is the final goal for here. So how we can check this? So now we will increase the size of problems. Okay, so now we know the solution for this part, this index we have, where we are including this as a base case. After that, what we will do, we will increase the size. Suppose we are including this part. Okay, so 3 by 2. Okay, now we have this. Okay, like 0 0. Now we have the solution for this. Okay, 0, this complete part. Now this is the solution for T4, and we have only this one part, so we can make tile like only this. Okay, so we can make like tile 3 by 2 only. Okay, there is no way to make the tile as a horizontal way in this. So in this way we can achieve only one solution. Okay, so that means what is the solution for if we have only this problem? So that means the solution, and we will maintain the solution in one another list. Okay, so then we will maintain like the solution that is 0 1 2 3 4. So this solution we have 0. Now if we are including this solution, so we have only the one possibility, 3 or 2, like the vertical tile. So 3 or 2, 3 minus 2 is the 2, and 2 after getting the solution, 2 plus previous solution. Okay, so this is the only one solution possible for this, so that is actually 1. We have achieved the solution. Now we have the minimum solution till this position, sorry, maximum solution till this position. Now we will include one more. Okay, so now we will include one more in this. So that is actually 2, 1, 3, 2, 0, 0. Okay, now this is the next part. Okay, so in this way, if we make this as a new tile, okay, so now we have already calculated solution till here. So here there are two way actually to get the answer. So what we will do actually, if we are making this tile as a vertical tile, so what will be the solution for this? Okay, so now we have the solution till this position. So we will, if we are making this as a tile, then what we will do, we will just consider as a t that, so t as a total score. Okay, so t as a index number 2. Okay, so t2 we are making this as a plus t3. Okay, so this is the one possible solution. Okay, and what is the minimum solution till this, and plus this solution if you are making tile like this. Okay, another way is like this horizontal way. If we are making this as a horizontal like this, okay, then we will get a answer, that means what is the total score for this horizontal things. So in this way we will get this answer 3 minus 2 and plus 2 minus 1, and we will add the previous solution for this t0, sorry, t4. Okay, t4. Okay, now this is the two possibility. Here we can write like this, so 2 minus 1 plus t3. So every time you need to check these two things. Just make that tile as a horizontal tile, or take the combination like this. So sorry, vertical tile, and here we will take as a two horizontal tile. So what is the solution? Okay, so that if we are taking vertical, then plus t3 solution. Okay, and if we are taking horizontal, then t4, that one after that, because here we are considering that tile is like this. And among these two positions, which one is the maximum, that we will store as a result here. That means if we, what is the solution of till this position, what is the maximum solution. So in this case we have 3 minus 2 1, 2 minus 1 1, so 1 plus 1 2, and so this is 2 plus 0. Okay, total 2. So this we are getting total 2 here. Okay, and but for the above one is, so 2 minus 1 is 1, and t3 answer is 1. So 1 plus 1 2. Okay, so both we are getting 2. So this final answer will be 2. Okay, so now this is the solution till this point. Now we will include one more. So that means 6 7 6 7 2 1 3 2 and 0 0. Okay, now till we got the answer. Okay, already we have covered this. Now we are including one more vertical elements. So we can make this as a one tile, and we will directly keep the maximum solution from this part. Okay, so that is actually 7 minus 6 plus what is the solution of till t2. Okay, that we will directly add. Another is if we make this as a two tiles. Okay, so then we will add like 6 minus 2 plus 7 minus 1 and plus t 3. Okay, then we will add the solution till this point. Okay, if you are making till this, and among all these, which one is the maximum? So 7 minus 6 is 1. So 1 plus t2, t2 is 2. So 1 plus 2 is 3. So we are getting 3 here. 4 plus 6, okay, 10, and t3 solution is 1, so 11. We are getting 11. So among all these, maximum is 11. So we will store the 11 answer here. Okay, and next is 8 9. So we will include now 8 9 in this. So 8 9, and this is 6 7 2 1 3 2 0 0. Okay, now we got the answer till this position. Now we will include this as a vertical tile. Okay, so the answer will be at 9 minus 8 1 plus t. And so this is the actually 0 index, so t1. So for t1 index we have the solution 11. That means 1 plus 11 12. Okay, now so that if we make like this, so we have this possibility 8 minus 6 plus 9 minus 7 and plus the solution till this point. Okay, so this is t2. So t2, what is the solution? So this is actually 2 plus 2 plus t2. So t2 is actually 2. So that is 2 plus 2 plus 2 6. 6. Among this is the 12 is the maximum. So 12 is the okay. So now this is representing the final solution from 0 to 4. Okay. So 12 is the maximum solution we can achieve by following this. Okay, so by filling this, so 12 is the maximum we can achieve. So this we can achieve by in any way. So this is the way to solve this problem using the dynamic programming. So here we are starting using the bottom up manner, and we are storing the result in one dimensional list, and we are making the base case, and we are including one index every time, and then we are checking the both conditions. So so this approach we will apply here. So I'm not sure this is done. Okay. Any query in this logic? Anyone?
Sir, logic we understood, but we'll take the program from the GitHub, like the code.
Solution you are asking?
Yeah.
Okay, so do you want to solution? So let me just write the solution also. Okay, so otherwise, what deadline we have set for this? We have set one more last day. So maybe
tomorrow night.
Okay, tomorrow night you will get a solution into one. Okay, so let me just write the solution for this. Okay, so. So here actually, reading input is also required because nothing is given here. So this question is not asking for the problem writing to a function. Okay, so input output format is given. Input format is given, and the first line contains the number of integer and the number of columns in the grid. This is followed by 2 lines describe the grid. Each of these lines consist of an integer separated by blank. So input is look like this. Okay. So 4 element we have, and 2 lines contains 4 elements. So that means this first element is value is representing number of elements, and now we have 2 lists. So you can read as a separate list and then perform the things. Okay, you can make as a function. So here what you can do, we can write the input reading thing. So that first value we can read as a input. So let me. Okay. So int input, and after that second we will read the list like n1 equal to that we can. So we have the element as is comma separate, that is space separated. So we have to make this as a list. Okay. So what we can do, we can use this list comprehension. So we can make int int of I, and we will read this as a for I in that input, and we will read. So one string will be completely read, and that we will strip that. Okay, and input dot strip strip, and then we will split. So strip is basically to remove the initial and last space, all these things, and then split. Split is basically if you're not passing anything, it by default it will that is split by the space, or okay, so this is by default. So this will read a one line, then second input we will read in the same way. So this will become a list 2. So now this is a okay, this is become okay, fine. So now this is input we have read, and after that we will perform the things. Yeah, so what is the possible input for this is, suppose if n equal to n, so we will 1 second. Yeah, so if someone is raising hand, please. Yeah, anyone have raised the hand? Oh, yeah, someone is. Yeah, Dev, what you're saying? You have pasted now? Okay, okay.
Yeah, sir.
Yeah, okay, thanks. It will save the time. Okay. Okay. So you can see here we are doing the same things. We are reading the input and the solve. We are calling this function, and now this function is called, and we have the input. If n equal to 0, we will return the 0 answer. Otherwise, we are maintaining this one list as a that this is a memoization things. Okay, here we are storing the solution of sub problems. Okay, here we are taking one more size. Okay, so we are including one additional size for the list n plus 1. Okay, initially we are setting all zeros in our resulted list. Okay, so 0 means we will start from the last position, and that answer will be 0. Okay, so that we no need to calculate the answer for that. That is actually by default stored 0. And you can see we are getting the solution for n minus 1. So that is when we are including the last index. This last index is representing when we are including only the last tiles. So how we can calculate the solution for that? So this is maximum of this first. We have two elements, okay, in the tile. The maximum of these two elements minus minimum of the two elements. Okay, so this is the first solution we are getting for this answer n minus 1 0. That answer, that n index, we have 0 value. Answer n minus 1 index, we have this new calculated solution. Okay, after that we will run a loop from the last tile. Okay, so that means we will include one more tile from the n minus 2 index, and we will repeat this process till 0 index. Okay, so 0, because of that we are taking minus 1. Then you can see we have two choice. Either we can make vertical tile or we can make two horizontal tile. If we are making vertical tile, then we will simply include that we will calculate the maximum minus minimum things, and we will add the previous solution of ans I plus 1. Okay, so we are actually at the current index I, so we will make as a vertical tile, as I mentioned in the diagram, that these things. So we will make as a vertical tile, and we will add the final solution. Okay, so like this 7 minus 6 plus t2, the next index from that. So in that way, this is the one possibility for the vertical tile, and we have the horizontal. Then we have two choice, two horizontal tiles. Okay, so this is the upper tiles, and this is the lower tiles. Okay, and then we will add the answer of I plus 2. Okay, so because horizontal tile will also consume one more that index. So among these two possibility, what and horizontal, then we will check the maximum amount. Okay, then we will store that answer into our answer.I index. So this is only a single loop. We will repeat till 0 index, and after that we will return a answer 0. What is the value at answer 0 location?
Sir, this line number 6 is for that empty, it is to make it 0 0.
No, it is not making 0. It is just including first actually that tiles. Actually, in this example, that if I take this, yeah. So what here, what we have the size of the list is 4. Okay, that 4. So what we are making ans that contain the 5 index 0 1 2 3 4. Okay, so that means initially we are setting 0 0 0 0 0 all. Okay, after that we are so this is actually n that n minus 1. Okay, so we have this n value 4, and this index is actually n minus 1 is representing to this index. Okay, so first we have filled all 0. That this is by default the additional as a base case. Okay, this is the solution for this additional steps. We are considering that as 0 0 like this. Okay, and we are storing the final direct solution from this index. So what will be that means we are only including this new tile at the first. So this is the only possible vertical tile. Okay, because this is the actual input for us. This is we have added as a base case, but this is the actual first index we are including in our problem. So this is the smallest problem. So this is the only two elements we have. We cannot make that horizontal tile for this. Okay, we can only make vertical tile. So we are directly calculating the solution for this is maximum among both. So this is 3, minimum among both -2. That we will add the solution of this T0. Okay, so that this is also not required. Okay, because we have included that as a final solution. So that we will store the solution 3 - 2 here. So this is the first step we are doing before the loop. Okay, this step we are doing before the loop. After that, we are starting our calculation from this index to 0, 1, 2. So 2 index to this 0 index, like this for each.
Okay, sir.
Then we have combination like this, vertical and horizontal too, every time. So we are doing this part actually inside this code. So vertical possibility and horizontal possibility. Okay, among these, we are finding the maximum and storing the result. So here you can see every time we are using the previous solution. We are directly adding. We are not computing that solution again. So in this way, this is simply a one iterative loop. Okay, and in this way, we can solve this as a in the linear time, big of n time. So yeah, this is the solution for this problem. So yeah, this is the one. And last problem, this I think we have covered this in our week 9 solution. So that we have this string S7598, 7598. This, and after that we can make a subsequence which for this string. But the condition is I think given here is which follow the above constraint. Okay, so above constraint is that the function return the number of non-empty subsequence that can obtain from the S, such as every digit in the subsequence is strictly greater than all previous digit. Okay, so what subsequence? If we have single digit, no problem. So we can take all single digit. But if we have more than one digit, then every digit should be greater than to the previous digit. Then we can consider as a subsequence. So 7, 9, you can see 7, 8, 8 is greater than 7, 5, 9, 9 is greater than 5. But this is the subsequences. Okay, we cannot take any random element from the strings. Okay, we have to follow the sequence. We can take as the 7 as, then we can take the element next character from the after that only. The order we will follow. So 7, 8 is 9 is there, 7, 8 is the one possibility there. So these combination we can make according to the constraint. So this is problem. I think this is discussed in week 9 live session. So I think the same problem is given. Let me check if this is done. Oh, live coding, yeah. I remember that. Yeah, this. No. Yeah, this is the same. Okay. So you can see this live coding session, that part. Okay, so that is already discussed in week 9 live coding solution. So that is also the dynamic programming approach. Okay. So I hope you can see this and try to solve this. Okay, so this is discussed in the last week, so week 9. All these problems are discussed, so that you can also focus on the another remaining live coding problems. So 4 problems are there. So this last problem is actually this is also taken from the OPPE exam. So I hope you can do this. So all the remainings are done. Okay.
The important for OPP, sir.
Important what things? Important topic.
Questions. Except these are.
No, we cannot directly tell you the question. Okay.
No,
so,
I'm not asking. No, I'm not asking.
Yeah.
I'm asking for the questions.
as I mentioned that no, what are the other possibility like linked list questions? So there are that insert node. Okay, insert node, delete node, and reverse the order of the elements, and like this swap the element or like first and last element swap. So that type of if you know the traversing properly and that update the reference, this 2 part, if you know that with the linked list, you can do any operation. Okay, like this.
Oh.
Okay, so this is from linked list. Then binary search based problems, that means if any question is asked for the log n complexity, okay, definitely just try to figure out the, just reach at the mid element and just figure out the conditions. How you can remove the half of the part. Yeah, Preeti,
Yeah, sir, did you say that sorting on a linked list is also part of the syllabus? Will that be asked as well? Is that a...
yeah, linked list is also a part. Yeah, linked list and sorting by default, it is also included.
Okay, yeah.
Okay, so generally we not ask straightforward question for the sorting. So like sorting is just sort the element. This we cannot ask because sort can be applied dot sort. But yeah, some problems where sorting is required before applying the logic. So if you remember one problems I in the B2 that where that problems. Let me just restate that. 1 second, just as example. Or either not B2, sorry, B1. PPA GRP1. Yeah, you can see this. Find min difference. Okay.
Yes.
So if you remember this, how you can achieve the solution for this? Simply perform the sorting first and simply just check the comparison of the 5 block. Okay, then you will get an answer for this. So this is, otherwise this looks like a the combinational problems, like you have to divide the all possible group of 5, then you have to try, but this can be solved using the sorting. Okay, because after sorting all closure element will come in the group, and then that will provide the minimum difference. So this type of problem where some sorting is required before applying the logic, that can be asked. Okay, and the same actually for use the greedy approach. Okay, you have seen in the greedy approach problems. So we perform some sorting things and then we applying the logic, like the interval scheduling. We have seen we have sorted the element by the based on the due date or that end time, like this. So some sorting is required for some problem, so that but generally not ask the question directly, straightforward sorting algorithms. Okay, so
From
that
graph, BFS, DFS, Dijkstra's, and MCST, Prim's algorithm.
so as I mentioned, any one algorithm from shortest path algorithm, one algorithm from that minimum spanning tree. But from the big four, yeah, definitely BFS you should know, and the related application of the that BFS. Okay, so that finding component and that number of connected component and reachability. So what are the relevant application for the BFS? You should know that. And similarly, topological sort. So that what are the problem can be asked for the topological sort based. You should know that.
In topological sort, course scheduling questions.
So that the dependency based question.
Okay,
And
sir.
I think you have already seen that type of question in your quiz exam, where some dependencies that pattern is given, that how many semesters is required to complete this, how many days is required to complete this. So that is the another one algorithm. Okay, we have the topological sort. So that two algorithm is also important in the topological sort. And topological sort also contain these things, BFS knowledge of these things. DFS is okay for the connected component and reachability thing, but that the same task you can do using the BFS. Okay, so that means BFS is enough if you know properly BFS only. And BFS, another application, we have to find out the shortest path. Okay, so that problem is also discussed. So suppose one problem I remember from the previous OPPE is that suppose if you have some network, computer network, and where the one computer is infected from the virus, okay, and now that computer is spreading the virus all to the all adjacent computers. So in this way, this virus is actually spreading into the whole network. And suppose if one unit time is taken from the spread the virus from one computer to the all adjacents, then they're adjacent like this. Okay, so in this way, what is the minimum unit time is required to that means all network is affected by that virus. What is the minimum time required? So that problem is actually framed on the BFS concept, where you can apply the BFS and find out the length of the shortest path. That means any maximum shortest path length. Okay, so that means we need to find out that the minimum time unit required to reach that virus to the every node in the connected graph. So that means you need to find out the path in longest path. Okay, so what is the longest path and how many that edge are coming in between. Okay, so that will be represent to the unit time, that time to affect all the system. So that actually is a sorting path, shortest path based problem. So you can achieve by the BFS algorithm. So here we are considering the number of edge in the path. Okay, so in this way. So that type of problem is one time asked actually in the OPPE exam, where you can apply this BFS approach. So that type of, the BFS topological. So in graph unit, just learn these algorithm. Otherwise, the remaining problems you have to apply the logic. Okay. Yeah, Dev.
Sir, I have a doubt in the connected components question.
Okay, so what's your doubt?
Yeah, if we have a graph and there is a node similar to the source node, there's a node where there is no incoming edges. Will it also be counted in the algorithm that we are using?
No. So if graph is directed, definitely this connected approach will not consider as a connected. Okay, suppose if this is given like 0 and the edges look like this. Okay, so 1 and like 2. Okay, so what happened in this type of case? If you apply your BFS from this node, okay, so 0 node, so that means it will check the adjacent, but there is no adjacent accordingly. Okay, so that means this is edge is coming to this, not going to outside of this. So that means you will find out that this 1 and 2 is not reachable from the 0. Okay, but another case, when you will apply this BFS algorithm on this, you can see 0 is now reachable from this. And when you apply this the BFS on this, now both are reachable on this. So now all are connected. So generally this finding out the connected component question is asked on the undirected graph, where you can directly apply your BFS algorithm to find.
Sir,
okay.
I have a example, and I have just made the connected components algorithm. I have written the algorithm, but it doesn't give me the valid output. So I copied the code from the summary, that GitHub thing, but that also giving me the same output. I don't know why. Okay,
so where is the problem actually you are using some
I gave an example myself, sir. I just gave gave some edges. I gave an adjacent list with having 3 connected components.
But just first tell me your graph is directed or undirected?
It is directed, sir.
So in that case, that algorithm may return the incorrect output. Because if you like this, as I mentioned, this graph.
There's an echo happening. Dev, can you correct that?
I am not sure. This is happening from their side.
Yeah, no, it's Dev's side. Yeah, sir, you could continue.
So, like this type of input, if you apply to start your BFS algorithm from this side, okay, so definitely you will find out that that if you apply this from 0, and this is not reachable. Okay, this is not reachable means this is disconnected from 0. In that case, our given algorithm will actually increment 1 count in the components. Because in our algorithms, what we are following actually, we are applying the BFS algorithm on the first, that 0 to in this way, 2 node. And when we apply in this 0 node, we will check that our 1 node is visited or 2 node is visited or not. So that means only this is visited. So we will consider as a 1 component. Now we will check that what are the remaining nodes which are not visited yet. So we will again apply the algorithm on 1 node. Okay, BFS node. So again, what we will do, we will because we have already checked from this and we increment our counter for the current component. Now when we are applying our BFS algorithm on this node, so now this will show that 0 is visited, but that we have already done. Okay, so that we will not consider again. So from this, again we find out that this is disconnected, and we will again increment our counter as a disconnected component. Okay, so then we will increment like this +1. Then we will apply this here, so +1. So in this way, we are finding out that we have three component, okay, for this graph. But if we apply our BFS algorithm from this side, okay, so suppose if we apply BFS algorithm on this side, at the first run you will get all visited. Okay, so you will get 2 visited, 1 visited, and 0 visited. So in this case, your loop will run only one time, and your all node will be seen actually in the first run. So here in the based on directed graph, that if your input is directed graph, then your this algorithm which is given in the our that course, that is actually for the undirected graph. So in this case, this order is matter actually, where from you are starting the BFS algorithm checking for the directed graph.
Yeah,
Okay.
so my case is a little different. Like I'm not getting a not valid count. I'm actually not even going through the other components. Like if you have different components not connected, it is only going through the first component, and other component are same as initialized. If it is initialized from by -1, it remains as -1, not even considering that for loop inside. No.
No. That I think that our approach will work on this type of information, because what if you remember this algorithm, I'm reaching at this algorithm. So let's see what the algorithm is actually. So not seen what is your case. So how that is actually working. So that graph algorithm and that BFS we have on that BFS, and here we have some application. So that simple BFS and path. Okay, so this application is, I think, in the last. Application. Okay, so find connecting component. Okay, so in this case you can see we have this BFS algorithm. Okay, so this is already given. Now this is the main part of the algorithm. So in this algorithm what we are doing, you can see we are maintaining was this scene one variable, and this is actually noting down that how many nodes are actually visited. Okay, so in this case we are incrementing this count. Every time what we are doing, we are checking if scene is less than equal to our all number of keys. So that means this number of keys is representing total number of nodes we have in the graph. Every time what we are doing, we are calling this BF. So we are considering one node. Okay, so that minimum that we are considering this condition, which is actually not visited. So that means component of I is equal to -1. We are picking the minimum label node from that, and we are calling this visited that BFS list on that node. And after that, we are getting a visited dictionary. So that will just represent how many nodes are visited from that node. And then we are traversing each node and we are checking if that is visited, then we are incrementing our scene to that number of times. So how many nodes are visited. So this while loop will run that number of times if so in our graph. So that we have just discussed now. If we have this 0, this type of situation, like this 1, 2, this type of situation we have, and we are starting the call from this BFS. Okay, so in this case, that means we have initialized scene equal to 0. Okay, 0. Now when we are applying this here, now we will check the visited list. So we will find out that only this is visited. This is visited, and the other node is not visited. So that means we will increment our count as a 1 because only this node is visited. Now we will again run a loop, because still this is the -1. This is still -1 not visited like this. So we will apply the algorithm again here. So again our scene will incremented by 1 from this position. So 1. Okay, so now how many times our that loop is running? So that is representing our number of component. Okay, scene is representing how many nodes are visited in each run, particular run. but how many times this loop is iterated, that is representing the number of component. So that algorithm, if you've seen that, this is that number return component. So okay, so this is the complete dictionary, and inside this this 0, this value is representing, max value is representing the number of component. So you can see this component ID, this is representing total number of component in this. So what you can do on the connected the directed graph, what you can do, you can run a BFS algorithm from each node. Okay, but that will not work. Yeah, this definitely, this approach will not work, which is given here on the directed graph. Okay, because here the connected definition is different. Okay, so here this is connected but not from 0. All nodes are connected for, but not from 0. You cannot teach from 0 to 1. Okay, so yeah, you have to update the logic. Yes,
sir, my doubt is that even if it is undirected, and then we have multiple connected components, like we have another connected component, more two connected components, then will it count? Like in our algorithm, will it count?
Yeah, definitely it will work. Yeah, then it will work. Yeah, definitely. Because what will happen, suppose if you have connected component like 0, you have 0 and 1. Okay, now you have separately 2 and 3 and then 4. Okay, and then you have 5 and 6. Okay, like this. Then what happening actually, we have total number of nodes 0 to 6. Okay, so 0 to 0, 1, 2, 3, 4, 5 and 6 total nodes. Then what we are doing, we are applying the BFS on 0 node. Then when we are applying the BFS on 0 nodes, so we will check our visited list after applying this. So that means from 0, this one will also visited. Okay, so both will be marked as a true, but remaining will remain false, because algorithm will only stop at this point 0 to 1. Okay, so in this case, that means we will run a BFS one time. Now 2 nodes are visited. Okay, so that means we will consider that as a visited now. So we will, in one iteration, we will increment our count. Okay, so that we will maintain one variable for the components, so that we will increment as a 1 count. After that, in the next iteration, we will check. Okay, so how many elements are now visited? 2, and total we have 7. Okay, so 2 is still less than 7. So that means still some nodes are remaining. Then we will check which nodes are still not visited. So that we are checking that we are maintaining some component things -1. Okay, so that is not visited yet, -1 all. So we will check all the -1, or what we can do, we can check all the nodes which are not visited yet. Okay, and among all these nodes, we will check which node has the minimum label. So label is the node value. So among all these unvisited nodes, we will pick this 2 and call the BFS on this again. And when we are calling the BFS on this, so the connected nodes will be considered marked as a true in this time. Okay. Now,
so
I'm
getting this thing, sir, but I'm unable to understand why it is not going for a directed thing. I have pasted the input and output for my thing. You can see that on the inbox.
No, directly definitely I mentioned this is the problem. Okay, because we are following one order to traverse this, and in the worst case, you are not able to reach the 1, because this 1 is not the adjacent of 0. Okay, so you will not consider as that when you are at 0, that you will find out what are the adjacent of this 0. So that 1 will not come in the list, because you don't have the edge from this 0 to 1. Okay, so in that case, your algorithm will terminate at this point. That will not move to the second node. So for this graph, this algorithm will return 3 components. If you are following the order for checking is 0, you are checking first 0, then 1, then 2. But just if you change the order for this problem, if you start from 2, then you will get the answer 1 for this, because from 2 side you will traverse all the nodes in the one call. So in directed graph, this is the drawback for this algorithm. It will not work on the directed graph. It will give the incorrect output based on what order you are following for the checking. but definitely it will work on the undirected graph. Okay, because undirected graph definitely 0 and 1 connected, 1 and 0 both sides we have the connection. So you have to update this algorithm for the directed graph. You have to figure out the logic. Then that means you have to check from the each order in this way. Okay, so you have to apply the BFS algorithm in this first element of from the first, then two, then, and among all the possibility you have to return the minimum answer. Okay, suppose what you can do, if you start from this 0, then check what is answer you are getting. If you can start from this 1, and you can see what your answer you are getting, then you can start from 2, then you can see what answer you are getting. Okay, so in this way, among all the possibility, then what is the minimum answer you are getting, that will be the answer. Because the connected component, connected definition is different for the directed graph. Okay, this is not the same as the undirected graph. That connected definition is also different. Okay, so here we can say this is connected 0 and 2 are disconnected. Okay, because we cannot, there's no path from 0 to 2. Okay, and 2 to 0 also. But here we can say that the 1 is disconnected from 0, because we cannot reach from 0 to 1. We cannot move to 0 to 1. But yeah, from 1, 0 is connected. Here the definition is also different for the connected things. Generally, this type of connected component question asked on the undirected graph where this algorithm will work. Yeah, for undefinite directed graph, you have to modify this algorithm. Okay. So what you can do, so I think you have posted something in the group. Let me see that also. So what you have posted? So you can ask, okay. So this, you are saying that this is a directed graph, correct?
Yes, sir.
And you are getting this answer. Okay. So you can simply apply the dry run on this. Just make a make a graph for this input. Okay, and just apply that your algorithm. Apply your algorithm, and because our algorithm is simply following the starting index like 0, 1, 2, this order. Okay, so we are checking from the always at 0 side. Okay, because our algorithm is always picking the minimum level among all the unvisited nodes. So that means we are always starting from 0 node, then checking how many nodes are visited from 0. If anything is remaining, then for the remaining nodes, we will again pick the smaller nodes one. But for the directed graph, answer can be different if we change the order. So because of that, you will not get a correct answer for the directed graph by this algorithm. Okay, so undirected graph definitely it will work fine. Or what you can do, if you are considering that for the connection, but one main change you can do. So suppose if you have A node and B node, okay, and you have this edge in the directed graph, and you consider that this is a connected, okay, both are connected. You want to just represent the answer. So what you can do, you can add the one reverse edge this. Okay, for each edge, just also include the reverse edge. So that means our the aim is here to just make this graph as a undirected. Okay, for each undirected, the directed edge, make the undirect reverse edge also. Then apply this algorithm, then it will work.
Yeah, that is good, sir. Okay.
Okay, then it will work. Okay.
Excuse me, sir.
Yeah, Preeti.
Sir, in the discourse post that you have made, where you listed out the important topics for OPP,
Yeah,
under the shortest weight algorithm, you recommend Bellman-Ford, right? What you were saying earlier, like everybody uses Bellman-Ford or something you said.
That actually code is easy to remember actually, because of that I said. Because this feedback we have got from the previous students actually. When I asked that which sorting algorithm you use, so most of them actually said that Bellman-Ford. because that algorithm was easy to remember for them instead of digest, and that actually also save the time actually in the code. If you are writing the Bellman-Ford code, so that code is actually smaller than the digest algorithm. That will save your time. Okay, so that is only this simple this type of loop is done. For digest algorithm, you have to write the big code that will take more time. Okay,
so from the
because of that,
OPPE perspective, we can learn any like we can use any algorithm, right?
you can use
From
any
within the
algorithm.
classes. Okay.
Yes. Okay.
Okay, sir.
Okay, so any other query?
Thank you, sir.
Okay, so try to do your best. Okay, so this is not a, there's no passing criteria for this. Just try to get the maximum marks. Okay, and no, don't take any pressure for this. Okay, then if there's no query, then we can close the session.
So whatever the marks we will get, that will be added directly to the, I mean, the end term, na?
In your final score, so 20% weightage this have.
So that means there will be 4 questions. Each will be, I mean, the
You
marks
can see
will
5 marks for the
so
final score.
if someone gets 10 or 20, that 20 will directly add to the
Yes.
to the
Yeah, in your final score. So each part have weightage. So end term, quiz 1, quiz 2, each have weightage, but this is contain 20% weightage in the final score. That means each question has the 5 marks. If you got 10 marks, that will directly add in your final score.
yes.
But there is no separate passing criteria for this. Okay, so you no need to just get clear this course or any at least 40 marks of it, like Python or another course. Okay. So I hope then we can close the session. Thanks everyone. Bye. Good night.
Thank you, sir. Good night.
Thanks, sir.